Rolling. All right, good morning everyone, and welcome live to Hesston, Kansas, in front of this wonderful new Ideal Combine. We're super excited to be here this morning with you and give you a first opportunity to look at this new project of ours in this wonderful combine. I'm Richard Conan, Marketing Director, and I'm here this morning with Caleb Schletter, my Tactical Manager for Combines in North America. So Caleb is going to go through the details of our program this morning. I'm here to say that the team has done really well to get prepared for this training and to maximize the next 3 hours and show you, everything that this combine's got to offer. So if we go back in time a little bit with this combine, this project started about 7 years ago, and with a quest around the entire globe to understand, what were the customers around the globe looking for into a single combine. Right, around performance, efficiencies, ease of use. What were some of the common themes and threads that the customers were looking for around the world, and for us to build a single platform and consolidate all of our engineering resources into this one combine that can be sold in South America, in Europe, and over here in North America. So really super excited. And in this process as well, about 4 or 5 years ago, we started including our North American dealers to make sure that we had a very strong voice of dealer into this project as well for North American needs. So all of your managers, so everybody listening, watching here this morning, all of your managers, in your leadership, your owner of the dealership have been involved in this project as well as far back as 2012. Okay, so definitely a very strong support from our dealer network, and ensuring that we have all of our North American needs fulfilled into this combine. So it's very amazing. I mean, we're super excited this morning to be here and to give you this first training event on the combine, and to open the path to our 2018 and going into our 2019 activities, but really to focus on 2018 and ensuring that you guys out in the field understand what this combine will be able to offer to you and your customers and how it's going to be different. So it's super, super cool. Yeah. We're excited. Caleb, I'm going to pass it on to you, and let's get the show started. So thank you very much for listening this morning, and we'll see you at the end of the training event.
Yes, sir. Thanks, Richard. I appreciate that. So as Richard said, we're going to be here for a little bit of time, and we really want to focus on what our key objectives are for the day. So the reason we're doing this is because this is the first step, that first drive towards 2018 and what our 2018 plan is going to be for the Ideal Combine. And what we wanted to boil it down for this group that's going to be viewing on YouTube or watching this show at a later date, we wanted to show you those high level, those key features that are different about Ideal that separate us from the competition. So there are going to be things that we're going to talk about. We have two great product experts, Brent Kosniska and Zach Stayskull. You'll meet them here shortly. They're going to go into each of these different modules into a deep dive. And they're going to tell you about what's going on with the Ideal Combine. What have we seen in our past tests? Why did we design it the way we did? And so it's going to be extremely crucial as we go through each of these modules for our 2018 plan that you guys have that in your toolkit, that you're able to communicate that effectively. So that's really where this built the virtual training that we're doing today. And this is a new style of training. We've done it a couple of times in the past, but this is really going to take us to that next level as far as having the machine here virtually for you guys sitting in an office, in your house, on the road even, wanting to make sure that you have all those tools in your toolkit to go out and talk to customers. So if we start talking about the agenda, we'll go ahead and dive into that. We want to make sure that number one, we're going to talk about what the training looks like. We're going to be here for about 3 hours, so we're going to do high-level product information. Then we're going to dive into the modular design. And that modular design is really going to talk about how we designed it the way we did and what that means from a global aspect. Then we'll go into the module deep dives. That's going to be Brent and Zach walking around the machine, diving into all those key different areas. And then finally, I want to talk about what does 2018 look like from a demonstration, from a customer event. We want to get guys excited. We want to show them the capabilities of this machine, and and we want to drive them to these events. So the 2018 Ideal Elite program is going to be some insight for you, the salesman, to understand what our 2018 plan is. And then finally, we'll close it out. So we plan on being here for about 6 hours, or 3 hours, excuse me. I was reading the number, 3 hours. And then from there, we'll let you guys go on your way. One of the key things that we wanted to allow you to do is ask questions. So at certain points throughout the training, throughout the exercise, we're going to open it up for questions. Now, there's a couple of ways that you can do that. What we suggest is right off the bat emailing my email account. So I'll be monitoring my email, making sure that any questions that come in are directed to the boys here as they talk. So caleb.schlater@agcocorp.com, and please put in the subject line Ideal Virtual Training. That's going to allow me to filter it out and make sure that we capture everybody who's asking questions. The other option is YouTube. We aren't going to be monitoring that as close, but what I will say with that is you have to be logged in order to ask questions. So if you do use that, we will have that up on a screen. If you do ask questions, you have to be logged in order to use the chat feature. So going into the modular design, when we look at this machine, when we look at what we're doing, we have a true global approach. So when you start looking at Heston, Kansas, for example, that's where a lot of our engineering effort has been in the past. This is where our grain handling module is being designed. This is where an electronics portion is being handled. And so what we've done is we've gone through and we've built modules in each of our key engineering areas. So Jackson, Minnesota is what you're going to see next. And Jackson, Minnesota is really who designed the track ride tracks. They're known for tracks. We use their expertise in order to do that. So we wanted to make sure we were utilizing where our key areas of expertise were around the globe when we designed this machine. So now as we move closer, we get into the Randers, Denmark, and Randers is really where our processor and cleaning design is. They've designed the dual helix rotors that we'll talk about, and the Ideal Balance harvesting cleaning shoe. So as you can see, we have a wide breadth of different areas. Then we go into now, with this site is the Sulati. And in Sulati, we are really handling a lot of the ground drive design, making sure that we're having that key ground drive, putting the power to the ground, and having that successful operation. Then, as we move further around the globe, you're going to see that now we're going to drive into good old Mochtoberdorf. And for those of you that know how powerful the Fendt 1000 has been and understand the technology behind it, that's really what's driving the technology in the Ideal Combine. So you'll see a lot of similarities between that Fendt and Challenger 1000 that you'll see in the Ideal Combine. Then we get into Braganza, and in Braganza, this is where our module design and production facility is. So this is where we'll be producing the Ideal Combines, especially in the first couple of years. That's where our machines will be coming out of. The next location that we're going to talk about, going all the way to South America, is Canoas. And in Canoas, that's where our feeder house and residue management was designed. So really wanting to make sure that the expertise in feeding, because we know how gnarly soybeans can be down there, we wanted to make sure that that expertise was incorporated into this design. We go back to South America, and we're going to go into Santa Rosa. And Santa Rosa is another manufacturing site for the Class 7, 8, and 9 for our South American. Because we are a global design, we do have different manufacturing sites around the globe. The next location, as you can tell, there's quite a bit of them, is back in South America. And this is the Mogi das Cruzes. And at that point, as you can tell from my fantastic Brazilian accent, we are building the ground drive in that area. So a lot of really crucial design elements are being handled, and what we want to make sure that we were doing is building that truly global machine. So managing that to where we were able to have a design that was accessible to the entire globe. How do we make sure that we have the machine that's that performs well in every corner condition around the world, we utilize our entire engineering force. So we don't just have Hesston building and engineering one combine and Berganza building and engineering one combine. We took the collective expertise of AGCO and pulled it together. So there's several key items that you're going to see and Brent and Zach are going to talk about that are extremely crucial and a product of this global effort. The first one is going to be the Streamer 6.0. So when we talk about that, that's going to be 6 bushel unloading. That's 485 bushel capacity grain bin. We'll talk about the dual helix and the importance of having 2 rotors and the way we design them and how crucial that is. We get into the ideal balance, which that is our cleaning shoe. Brent and Zach will deep dive into that and show how we mitigate hillsides, how we make sure we're providing a clean sample out of the gate. Then also, we'll talk about the tracks. So our track ride option, as everybody knows, Jackson is known for tracks, and we're really excited that this is an AGCO-produced track system, an engineered track system, utilizing those key ideas and elements that really have built our track tractors to success. So those are just a couple of very high-level key things that you're going to hear about today. I greatly appreciate you taking your time today in order to dive in and invest into the Ideal Combine. What I'm going to do now is I'm going to hand you off to our product expert, Brent Kosniska, and he's going to start off talking about the feeder house and really showing you how we've made things different on the combine. So thank you again. And Brent, why don't we go ahead and hand it over to you?
Will do. Very good. Thank you, Caleb. So as he mentioned, my name is Brent Kosniska. I'm the Senior Marketing Product Specialist for the Ideal platform here in Hesston, Kansas. And kind of what we're going to walk through today, there's a lot of things we want to share with you, a lot of unique things that are truly unique to this combine in the marketplace today. And how we're going to kind of introduce this to you is starting at the front, working through the crop flow of the machine. So we'll start at the feeder house, into the processor, into the direct discharge, down to the shoe, and then, of course, to the residue management, grain handling. Now, the first thing we'll discuss up front is our feeder house. And you can see this is a very, very large feeder house up front. We have, in this model, which is our Class 9, we have a 4-strand feed chain design. Now, as I mentioned, we'll have a Class 9 machine, but we're also going to manufacture a Class 7 and Class 8 machine. The Class 7 and Class 8 will feature a 3-strand feed chain. And really, when we do that, all of our testing that showed no factors as far as any reduced reliability having that 3-strand design. Going up to the 4-strand design was necessary when we're running those 45 and 50-foot platform headers that are capable of being ran on this specific combine on that Class 9. The other thing to mention when ordering this combine, we have the option for a manual pitch frame and a hydraulically pitched frame up on the front. So what that will allow us to do is to pitch this feeder plate either forward or back. And really what that's going to allow us to do is to, on the fly, adjust our header angle. If we're in down crop or in down corn, we can adjust those snoots up or down in order to improve feeding performance. One thing to keep in mind is on the manual pitch frame versus the hydraulic pitch frame, they are 2 completely different frames. So if you order a machine with a manual pitch, the faceplate will be adjusted down on the side of the machine using tools and adjusting hardware to adjust that angle. If you do order that, it's going to be very difficult later in life if you have another grower that wants to have the hydraulic pitch frame to install that on the machine. So be very conscious when you are ordering this. If a hydraulic pitch frame is necessary and you want to look at resale and look at the capabilities with that feeder pitch adjustment, the hydraulic pitch frame is something that you definitely want to consider using. So how is this adjusted on the hydraulic pitch frame? If you want to follow me down below here, what we do have are 2 cylinders up underneath the feeder house. And as I mentioned, controlled from the cab, it's a very simple adjustment. You got 1 on each side. But once again, this gives us the opportunity then to pitch that faceplate forward or back in order to improve our cutter bar angle with the Dynaflex, or like I mentioned before, in down corn versus standing corn, having that adjustability on the fly from the cab really can improve cut performance. The next thing we'll talk about on the feeder house is our tilt frame. So one of the things we did change compared to what we're used to in the market today, and even our combines that we produce today, is the fact that we only use 1 cylinder for our tilt frame currently in production. On the Ideal Combine, we actually take that and incorporate 2 tilt cylinders. We got 1 on this side, and then there's another one right on the other side of the feeder house frame that looks identical. What this is going to do for us is going to be a lot more responsive. It's going to be a lot more reliable as far as that tilt mechanism frame. But your automatic header height control, you're going to get some nice reactive responses out of that compared to what we've seen today in the marketplace. So one other thing to keep in mind when you're running this feeder house, you ask the question, I get it a lot at farm shows, is, well, what happens when you plug that feeder house? And yes, you can. Let's talk a little bit about how we reverse this system when we walk back here, and you can follow me around to the back side of the machine. We'll look at our reverser for this drive. So our header reverser is controlled from the cab. It's a simple switch. You just take your header engage, you rock it back, and this hydraulic motor will engage. And up here, this is our upper header drive gearbox. Okay? We'll walk through the drives a little bit later. This will make a little more sense. But hydraulically actuated, it will reverse the front feeder house. It's a very simple drive. It's very simple to engage and control from the cab. And it's going to be a very robust design as well. Okay? With that, Zach, why don't you talk a little bit about feeding as we come into this feeder house?
So one thing I want to highlight really quick here is something that Brent mentioned about that creep mode. So we're going to have the ability for to use that creep mode when we run into things out in the field, such as the beaver huts when you're picking up swaths, or just some nasty down crop. Maybe you plugged up the header and you're taking in a lot of crop all at once. So the cool thing about that creep mode is how it helps feed the next section that we're going to talk about, and that'll be our rotor feeder section. So highlighted on the screen here, I've got the single helix rotor feeder. A few things that I want you to notice that are unique about this design are the flightings on the outside. So the flightings on the outside of this beater are helping feed the crop to the inside of the beater. We have a 4-paddle design. This is 24 inches in diameter. And but back to those flightings, those flightings help feed the crop to the center of this beater. And on the next slide, I'll show you here also the intake. So the intake on that rotor feeder is going to help funnel that crop into the single helix rotor, into the intake flightings on that rotor. And this is unique to the Class 7 only. Now, next I'll show you the rotor feeder for the dual helix design. So as you can see, we still have the 4-paddle design, still a 24-inch diameter, but now we've got small flightings in the middle to help kind of divide that crop out to the right hand and the left hand side. Also to divide that crop out to the right and left hand side, we've got the dual inlet for the dual rotor feeder. So one thing that's really important about this is we can help divide and evenly feed that crop to the twin rotor, the left hand and the right hand. Next feature, while we're in this area, right in front of the intake, kind of right in that rotor feeder area, I'm going to talk about the feeding transition. So the cool part of this design is we're feeding the bottom part of the rotors, the bottom part of that intake flighting. So that's one thing unique about this combine compared to others on the market, is we're not feeding the direct middle of this rotor right here in the middle. We're not feeding right there, we're feeding here on the bottom, so we don't create the pinch points and kind of the traffic jam that other combines might by feeding the bottom of the flighting on this rotor. Another thing I want to talk about quickly while we're in this area is our stone trap, our rock trap. That's located, as you can see here, we've got shadowed out right in front of that inlet, right around that rotor feeder area. And Brent, why don't you show us a little bit of functionality real quick on that rock trap?
Okay, Zach, we'll do. So we are up underneath the feeder house right now. We do have our safety latch on the cylinder, so we are completely safe up underneath here. What Zach's referring to is our rock trap. So right in front of that inlet, right underneath that front rotor feeder, this is our rock trap. It has a very easy mechanism to open and close it. It's just a simple over-center latch over here on the right-hand side of the machine. And I'm just going to simply pull this down, and you can see how simple this is to access up inside. It's a little bit difficult to see, but I can actually look right at the rotor feeder from this angle. The other thing, as material comes out of this rock trap, we have this rock trap slide. So once again, this is just a simple diverter to keep that material from coming down onto the transmission. But this would be a very simple operation to do. If you're running down on the ground in soybeans, for example, this is something that we'd probably want you to do daily. So this is a very simple latch, over center latch, very easy to access and to open. With that, Zach, we'll head back over to you.
So next thing I want to run into is the heart and soul of this combine and talk about the combine processor. Really talk about the differences between our Class 7 and our Class 8 and 9. What makes this combine not only unique to AGCO, but makes this combine unique to the combine market. So on the first slide here, I wanted to highlight basically some key differences between our Class 7 and our Class 8 and 9. On the left-hand side, you could see that rotor feeder and the inlet that I was talking about before. That's going to be, pushing that crop into the middle, feeding that into one single rotor. Now on the right-hand side, I've got the rotor feeder highlighted here with that intake, and you can see we have a twin helix design instead of the single helix in the Class 7. So let's dive a little bit more in depth to this. We've got a little bit of a breakout here of the single and dual helix rotor. So for the single helix design, starting off with that, the top rotor is going to represent the right-hand side rotor. And our intake area on both rotors is going to be about 21 inches. So the flighting on these rotors are going to help feed our threshing area. That flighting is really going to help feed into what we call our double staggered RAS bars. So we've got 2 sets of 4 RAS bars, and they are perfectly staggered. We've got about 4 feet of threshing area there. Now through the intake and the threshing area, your crop mat's going to see about 2.5 revolutions. We want to do 100% of our threshing in the threshing area, and we want to do about 85% of our separating in that area as well. From the intake and threshing area is where we're going to see solely our concaves. We'll get to those in a little bit, but one thing I want to highlight here, that's where you're going to see where our concaves are oriented and adjusted. Now moving on to our separation area, we've got 97 inches of separation area. That's where we're trying to separate that last little bit of grain from our crop mat and use what we call our separator tines to really help move that crop through there. As you can kind of see on here, we have 4 different rows of helical design on these crop tines, and with guided vanes we use that to move crop through. It's making 4 revolutions in this separation area. So from the beginning right over here in the intake to the end of the separation area, we're making 6.5 revolutions through these rotors. Now the last little bit of area here is what we call our direct discharge, about 2 feet of length right there. We're going to be able to discharge this MOG into a chopper, or if you're wanting to lay a windrow, directly discharge this MOG right through our discharge chute and right onto the ground. So I'm going to jump into a competitive comparison here a little bit and show you why our rotor is unique compared to the competition. So as you can see, we have the longest rotor on the market at about 16 feet. And what really makes us unique to the next longest rotor and the competitor's hybrid is that their rotor is used for separation only. So for our rotor, we're using it for threshing and separation. Now, when you compare it to the bottom comparison there for the competitor's dual rotor, the next true dual rotor, we're about 87 inches longer than that rotor, and we are also a larger diameter. So that's where we're getting our threshing and separating volume in this combine, where we can really push high capacities through different crops. I want to talk a little bit about our concave adjustment. On the left-hand side here, we've got the single rotor concave adjust, and on the right-hand side we have the twin rotor concave adjust. They're going to work both very similar. They're hydraulically adjusted. On the left-hand side you use a single cylinder. On the right-hand side you use twin cylinders, and all these linkages right here move in time at the same time. So you're not rotating about the center, rotating about the outsides. They're all dropping and lifting at the same time. So now that I've covered a little bit of the concave structure there, let's go over to Brent and talk about what concaves we offer in this combine.
All right, Zach, well, while you were doing that presentation, I went ahead and pulled all these grates out of the combine. Well, maybe we had them out already. But the first one we're going to walk through, we'll walk through some of the concave options that are available for the Ideal Combine, and then we'll kind of move back to the separator grates. So the first one I have down here is our small grain concave. This will be using a small wire concave wire on a tighter spacing. Then also up at the front here, this is blocked off. Now this is going to give us that extra threshing capability when we get into those tougher threshing, small grains, barley, whatever it may be. But this is going to be standard on all small grain configured ideal combines. The next one we can talk about here is going to be our large wire concave. Now notice how, these are robust. These are very heavy designed, but they are still light enough to manage and easily install and remove. So this one here is going to be our large wire concave. This large wire concave will primarily be used in a drier corn, a drier, lower yielding, mid yielding corn. Also works very, very well in soybeans. Some of the things that we can pull out in soybeans as far as sample quality and cracks and splits, it's so minimal. This is something that is very impressive when Zach's talking about the threshing performance and the separating performance and how gentle it is. Having a nice concave design really supplements that. So like I mentioned, this will be primarily on soybeans, dry corn. Our next option is going to be our round bar concave. Now this one is going to be primarily used in higher yielding, higher moisture corn. And for those of you that are watching, this is very similar to what we offer on the market today for our current machine, right? These concaves are all things that we're used to on our axial design. And as far as the use cases for each of these concaves, it's pretty well the same theory of operation that we have in our axial today. We'll transition back to our final grate that I have on the ground. And this is going to be in the separation zone. Zach mentioned how large our rotors were, so these will be the back grates in the back of the rotor configuration. This grate here is our skip wire grate. Notice how wide it is. Now, the thing to keep in mind with this is not going to be standard on the machine as far as the small grain configuration goes. We'll get into the grates for that machine here shortly. This grate will be used if you're running into issues with rotor loss. If we are starting to have material slip out the back of the rotors and not separate down to the shoe, putting in a larger grate is an option available after all settings have been tried, of course. But we do have that capability, those tools available if need be in certain adverse conditions. So having the skip wire grate can be used in corn, and high moisture corn especially. The step finger grate is what we'll talk about next, and we'll walk up to the machine, and it's installed in the machine yet, and we'll get a closer look on that as we go right over here up inside to the separation zone. So I did not pull these out of the machine. This is a small grain configured machine, but you can see the step finger design on the grates. This is going to give you a little bit of lift as that material comes down through the separator grate to help stratify that material and to get some extra separation. So as I mentioned, a great soybean, a great small grain separator grate, and for most of the corn that we run, this grate will work as well. Okay? While we're up on the machine, I think it would be appropriate at this time, Zach, you've talked about a lot of the features of this processor. Let's talk about how we can reverse this processor in case of a plug. Now, I always get this question asked, how do you reverse it? Do you have a reverser and can it plug? And I'm going to say if you don't plug a rotor, you're not trying. So yes, it can be done, but we do have a very robust design on the back here to unplug our rotors on this combine, whether it be the single or dual helix drive. So similar to our axial design today, we have a hydraulic motor. It's a very high torque. It's going to turn very slow as well. But this will hydraulically engage into the ring that's right around our variator for our rotor drive. Now, as I mentioned, this is controlled hydraulically. It's from inside the cab. You can pull back your rotor engage switch, and that will slowly reverse your twin rotor, dual helix, or single helix rotors right from the back of the machine here. Once again, very robust design. If you do get into a situation where you have plugging, we can definitely avoid that or alleviate that issue by the reverser. Now, as Zach mentioned, one of the things that helps us kind of alleviate the issue of plugging or try to avoid it is our concave frame itself. Having that spring-loaded option with the hydraulic cylinders, that cage can drop down and allow a slug to pass through rather than having a fixed frame that will be rigid and allow that crop to get wedged or slugged into the rotor. Another thing Zach mentioned was our discharge. As we continue that crop flow from the front of the rotors, we go through the threshing zone, the separation zone. The final thing we can really talk about here is the discharge. So I'll go ahead and have you follow me in, and we'll take a look at the rotor discharge at the back of the machine. So as mentioned, up here at the top, you can see this is the back couple feet of the rotors. So this will be the left-hand side, the right-hand side, and I'm sitting directly right now in the chopper chute. So as material transitions from the threshing zone to the separation zone, you're going to notice now this is the discharge zone. That material will directly discharge out the back of the rotors, come down this chute, and as Zach mentioned, if you're going to be dropping a windrow, this will just fall directly to the ground, or we will have our chopper rolled forward, and this material would be processed then through the chopper and spread out the back of the tailboard. So we've kind of walked through the entire process up to this point. We've gone through all of the feeding, the processing system, and the direct discharge system. I think to bring it full circle to really show you how the system works, we'll walk through a quick animation to highlight some of the features that we just talked about. From here, I'll pass it right back over to Zach.
Thanks, Brent. Like Brent said, I'd like to cover a real quick crop flow animation to just basically summarize what we've covered in the last few modules here. So let's take a little journey through here. So we're going to start off on the front part of the machine here, basically taking from what we're getting in our header through our feeder house. So you can see here we have, like we are showing here today, the 4-strand feeder chain on what would be a Class 9 combine, feeding that crop into our rotor feeder. Now, one thing I want to pause and highlight right here is that our rotor feeder speed is directly proportional to our rotor speed. So our rotor feeder speed is 70% of what our rotor speed is. So basically, if your rotors are running at, for instance, 1,000 RPM, running at 70%, our rotor feeder would be running at 700 RPM. So just some quick math, easy numbers there for you. We're going to take this crop mat from the rotor feeder here and feed it into the intake. So the first 20 to 22 inches of the rotor. And one thing I want to highlight real quick is the flighting on the front part of these rotors and how it feeds, as you can watch this through, feeds this crop into those staggered threshing bars right here. So from here until here, we're making 2.5 crop mat revolutions from our intake to our threshing area. So that's, once again, like I mentioned before, we want to do 100% of our threshing right in this threshing bar area right here. We want to do about 85% of our separation as well. So as we follow this crop through the rest of the processor, you can see how we have these guide vanes. These guide vanes help us move crop through our rotor system, but also at the same time, we want to make sure they're not too aggressive so that they're getting enough time in there to thresh and separate. And as Brent just covered, dropping back down into our direct discharge, right here, we're going to dump into the chopper, or if you're laying a windrow, we're going to slide that chopper back and lay a good windrow with some really nice straw quality without having a accelerator or any kind of discharge beater in there. So a lot of high straw quality that comes out from these rotors, and that's one thing when you're laying windrows too. You get nice long straw, and with the gentle threshing in these rotors too, it's aggressive enough threshing, but also at the same time we don't really have to worry as much about grain damage. We get high sample quality from these rotors because of the amount of time that we can spend in the rotors, but we don't have to be overly aggressive. So from that, we want to stop and open it up. If there's any questions that you guys might have from the first couple modules, if you guys have sent anything to Caleb, or if you have anything, speak now, or we'll cover it again in the end as well.
Okay, Zach, so we did have one question arise here, and it was in regards to our hydraulic pitch on the feeder house.
Yes.
So the question that was brought in is, if I'm running a header that already has hydraulic pitch on it, our current 3300, our current 9250, how do we manage that system? Do we run both of them? Will there be a lockout on the header that we'll want to install, and then we'll just simply use the ideal feeder house?
So what happens with the software in there is when you're running, so you basically in the terminal you'll set what header you're using. So say you're using a 3000 series corn head or a Draper header. The software is going to use it so that we use the combine pitch and not the header pitch. So basically, what your header pitch is set at is what it's going to stay at. So we'll use the combine pitch and not the header pitch. We won't use them in tandem. We want to use this ideal pitch design for our headers moving forward. So I hope that answers.
And one thing I'll add in addition to that, Dynaflex headers coming off the line, 3300 corn headers coming off the line. For the ideal platform, we'll have a lockout. So there will not be cylinders on those headers from the factory when they're going to be installed on an ideal combine. Now the capability to go back and install them later is if running on an older machine, that's something that can be addressed at that time. But from the factory, for ideal combine configured headers, they will not have the pitch cylinders installed. The next thing we're going to do, we're going to walk through the cleaning system. We've gone through the feeding, the processing. The next part of the process is going to be our cleaning system itself. So with that, we're going to transition to the slides and continue this journey. So the cleaning system in this combine is something that I'm really excited about. It's truly unique in the market today, how we deliver material from the processors down to the cleaning system itself. There's no one else that does it this way, and I think this is done purposely. This design that we have really, regardless of crop conditions, can deliver a nice even distribution down to the shoe, regardless of hillsides up to a certain point, and regardless of crop conditions. So let's dive into a little bit of a breakdown of how this system works and how we're so successful with it. The first thing we'll talk about is our ideal balance return pan system. Now this will be only configured on a dual helix rotor machine, so on a Class 8 or a Class 9 twin rotor design. If you follow along on the slide, you can see the orange arrows on the back. That's going to depict the separation zone of our rotors in themselves. So material separating out the back of the rotors will be channeled on this return pan to be distributed down to the outside edges, outside couple rows of the stratification pan, which we'll dive into next. You can kind of see it ghosted down here. So the separation zone is going to be channeled and directed towards the outside of the stratification pan. The front pan up here is going to take the material from the threshing zone, and it's going to distribute it down to the stratification pan at the very front and across the center of the strat pan. The image down in the bottom right corner really depicts how this works. The information off the grain material off the front pan, as I mentioned, is going to be distributed to the center 4 rows of that stratification pan. And as you can see, the bottom return pan, this is our rear return pan for the separation zone, is going to incorporate that material to the outside edges of the strat pan. In essence, what this will do is going to deliver us a nice even distribution to that stratification pan. As I mentioned, regardless of crop conditions, that material is going to come down to that stratification pan the same every single time, which once again, there's no one else on the market that does it this way. We're really controlling how we incorporate that material down to the shoe with this design. Let's walk through what the single helix return pan will look like. It's going to be a little bit different, of course, with only one rotor in the machine. So as that material comes out of the rotor, you can see the vanes that we have on this return pan are going to start directing that material towards the center of this return pan itself. As that material shakes forward, we're going to see that we're going to start to even it out once again onto that cleaning shoe up at the front. So the idea behind this is to channel the material towards the center, and as it gets up towards the end of the return pan, or in this case it would be the front side of the return pan, we're going to start distributing that material out onto the shoe nice and even. So we've had great results with these designs. The Class 7 is a great performer. It does a very nice job out in the field, like I mentioned before, and soybean, some of the things that we're seeing in the sample is just incredible. And some of the things that we're talking about here, delivering that material evenly across the shoe, and some of the things that I'll talk about here next are some of the other secret keys that we have that deliver the success that we're seeing in this combine. So I've alluded to it a couple of times, and the next part of this process, as that material comes down off of the dual return pans we call ideal balance, or as it comes off the single return pan, we're going to incorporate material to what we call our stratification pan. Now, the whole sole purpose of this stratification pan is exactly what it says in the title here. It's going to stratify grain. Now, the grain itself is going to be incorporated onto the stratification pan evenly, but it's also going to be mixed with MOG, material other than grain. So you'll have cob, you'll have lighter sticks and stalks, you'll have threshed and unthreshed pods potentially. Now, the goal of the stratification pan is to separate the clean grain down towards the bottom. And you want the lighter chaff and other material to be suspended up towards the top of this stratification pan. Now, how we do this pan is connected to our shoe frame. So this pan will shake with the shoe frame, and as that material progresses back, the louvers on the stratification pan will help stratify that material. So as we progress towards the rear, and as we fall off of that stratification pan, the goal would be to have heavy grain, nice clean grain at the bottom of the pan, and the lighter chaff, MOG, up at the top side. And this is where we're really successful with this design. As we incorporate that material off of the stratification pan, which is right up here, so this is your stratification pan. At this point, we've stratified that material. The heavy grains at the bottom, the lighter chaff and debris is up at the top. The key success here is that we're going to have a series of drops. And when we do that drop, we're going to hit it with an air blast from our cyclone cleaning system. So the heavy material is going to drop. On the first drop is about 4.3 inches. So that material drops, the air blast from our fan is going to come through this upper duct, and we're going to start suspending some of that lighter chaff, that lighter MOG. It's going to start getting thrown out the back of the machine. It's going to start at least suspending it towards the rear of the chaffer. Now we have an intermediate pan. It's going to be the same type of louver system that we have on our stratification pan, but once again, this is just one extra little step here to once again stratify that material. Get that heavier grain down to the bottom and try to get that lighter chaff up to the top. The next drop we have is about 3.4 inches. Once again, as we drop, we're hitting it with a blast of air to help stratify, help suspend that chaff and debris out the back of the combine to leave the nice clean grain sample to be processed on the chaffer itself. The next part of the process we can talk about is our cyclone cleaning system. You can look at the fan design. We go into basically a segmented fan design. The series of 3 paddles, a large volume, high capacity cleaning fan. Having enough air in this system is not the issue that you'll have with this combine. You can notice how the airflow goes through the cleaning system itself. So the design that we have here, it'll run about 1,350 RPM, but the key thing to note is how we deliver that air to the cleaning shoe. Now, we've already talked through the stratification process, how we have that upper blast. And then in addition to that, we have another blast of air that comes off that intermediate pan. The next step that we need to do is deliver nice full length and width cleaning air all the way through our chaffer and sieve. Now, in this image up at the top here, you can see that we have deflectors located throughout the bottom of the cleaning shoe frame. This is going to place that air exactly where it needs to be. These are placed scientifically through a lot of studies, through lab tests, through lab studies, through field tests. So these will deliver the air in the exact places that it needs to be on that clean shoe. Next, we'll move into the chaffer and sieve. So the chaffer and sieve options that we have available on this combine are very similar to what we offer today in our axial combine. We will offer a corn and soybean configuration, and we'll offer a small grain configuration. One of the things that we want to highlight here is the differentiation we have between our class sizes when looking at the length of our cleaning shoe. As I mentioned, we'll have 3 models available for starter production. It'll be the Class 7, 8, and 9 machines. And the thing to keep in mind here is the Class 9 machine is going to be a little bit longer on the chaffer and sieve. It's going to have a little bit more cleaning area. The reason for that, not only is a customer going to get that extra gain when he makes that investment up to a Class 9 machine, but mostly we're going to be running larger headers on Class 9 machines. The extra cleaning is just going to give us that much more capacity and throughput when we're running in those larger, heavy yielding crops with larger headers. If we're running a 45, 50-foot header on a Class 9 machine, we need to be able to keep all that material on the chaffer and get it delivered up into the grain tank. Now you can see the square inches that we have available on the Class 7 and 8. We're going to be right at about 13,640 square inches, which puts us very, very well in the marketplace today when you look at the competition. In addition, the Class 9 is going to be over 14,400 square inches. So once again, when you look at the competition and how we stack against them, we're going to be very, very competitive in the shoe size when we're looking at both of these models that we have here, all three of these models rather. Now, one other thing that's unique about our chaffer and sieve is the installation and removal. And I really appreciate this. If a guy does need to go through and change that chaffer and sieve, I'm going to transfer it over to Zach. We've got one pulled out. I wanted him to show you exactly what I'm talking about.
So now that I'm on camera, I do want to do a really quick introduction of myself that I didn't get covered earlier. My name is Zach Stayskull. I am currently a marketing product specialist in the hay and harvest side here in Heston, Kansas. But formerly, I was with Engineering Field Test. And so it's been kind of nice to see this combine from a couple point of views, chase it around the world and back. Now, being with Field Test, this is one thing that we all know. You got a big chaffer, big bottom sieve. It's a pain to install, it's a pain to take out. So one thing that we really wanted to do with the new design is go with a split chaffer and sieve like we have here. Now the nice thing with the split chaffer and sieve, it really eases our installation, it really eases our removal as well. We all know that a little less weight in there is a lot easier to make this easier for one or two guys to do. Now one thing I want to highlight is these fins here. We have divider fins. Now these can be taken off as well, depending on what you're seeing in the field. Now this is a Class 9 chaffer, so this is what you're going to see. This is the bigger one. Like Brent mentioned before, between the 7 and 8 and the Class 9, we have two different sizes, so this is the bigger one. Now while I'm here, I want to rotate it around to the back side and show you guys a little bit about our adjustment. So basically we have an adjustment handle, adjustment latch here, and that's going to be electrically actuated, and that can be adjusted from the cab. You'll get your clearance readout from the cab, but also we have a control panel on the side of the combine. So if you're down doing some maintenance, taking some measurements, just wanting to make adjustment on your best judgment, what you're seeing in the field, you'll be able to do that from the ground right next to the chaffer and sieve frame there. So from that, I'm going to talk a little bit more about our tailings module. So as you're taking that grain off the bottom sieve and you're going down to your tailings return, we have a cross auger on the bottom of the combine that runs across and is driven on the right-hand side of the combine. Now that tailings cross auger is going to be bringing material into this tailings elevator right here, and that tailings elevator is gearbox driven off the drive from the other side. Now, cool thing about this tailings elevator is we take it up to the top. Through here, it goes past a tailings volume sensor, so in the cab we can tell what our tailings volume's like. I mean, are we seeing too much, or that's another way we can make adjustments to the settings of this combine. Now, another thing that's unique about our combine is where we dump our tailings material. You'll see on other models that they dump the tailings material into the rotors. What we're actually doing is we're dumping our material back onto our rear return pan. The point of that is to keep from overloading our rotors, and also a feature of this tailing system is our rethresher door. So here what we have on the combine now currently is a smooth rethresher door. We have a finger paddle inside here with little serrated fingers on the edge. The point of that is to help not only move material, but thresh some hard threshing material if needed. Now, if you start getting into some small cereal grain crops where you're starting to get white caps, or you're having issues really getting that hull off the kernel, we also offer this serrated door. As you can see, we've got fingers on this serrated door. Now, what we suggest with this It's a quick and easy installation. You got an over center latch, and you just hook these right in behind the hooks. But that comes with every combine. It comes in the toolbox of every combine, and we suggest that in some cereal crops if you are having some issues with threshing and getting white caps in your sample. So instead of overloading our rotors, we really would like to do a little bit of extra threshing here in the rethresher door if need be, and then use our cleaning system to send it back through and keep cleaning that material so we can get a really high quality sample in the grain bin. So from that, we've kind of covered all the way through with our cleaning system and our returns and how we're going to re-clean. I'd like to pass it off to Brent and see if I think he's going to show you guys a little animation from start to finish of how our cleaning system, our ideal balance system works.
All right, thanks, Zach. So this kind of does a recap of the material following through the threshing zone up into the separation zone, and you can start to see the material start to incorporate down onto the cleaning shoe itself. Now we'll continue this animation around, and we're going to take a deeper dive into each of these return pans. And once again, these are truly unique on the dual helix rotor machine on how we take that material from each of the zones on the processor, starting out here at the back, which is going to be our separation zone. And look at the design of this pan. What it does, it's designed in order to channel the material, as I mentioned, from the separation zone, and that's going to shake forward and deliver it towards the outside of our stratification pan. The next area that I want to focus on, and we'll play through this animation, is going to be up here at the front. So this is our front return pan. It takes the material from the threshing zone, and it's going to deliver that towards the center and the very front of that stratification pan. Now, while we're at this spot, I think it's also appropriate to talk about our tailings return. Zach just walked through how that's driven, some of the tools that we have available if we need to increase our returns threshing capability. But this is a good display of how that material is delivered back to the dual return pan system that we have. So that material will be delivered towards the back pan, towards the front half of that system itself. So all of our rethresh that we're doing with this combine is going to be done post-threshing. It will be done as a rethresh back here at the back. We're not going to flood the processors like he mentioned. So this is a great design. It's been very bulletproof for us, and it's delivered great results, even in those tougher threshing small grains. As we continue that crop flow, we're going to circle around and we're going to start delivering that material down to the stratification pan. As I mentioned, the goal with this design in every condition is to deliver a nice even crop mat throughout the entire process. Once again, I'll beat it to death. The goal of this stratification pan is to strictly stratify the grain and get two separate layers of crop material. That's going to be the heavy grain towards the bottom and the lighter chaff towards the top. This animation will then go into our airflow, and the key behind our airflow is where we place that air in this process. So as I mentioned, the first one will be during our first drop off of the stratification pan down to the intermediate pan. In addition to that, we'll do one more drop off the intermediate pan down to the chaffer and down towards the cleaning shoe itself. We incorporate another air blast. What that's going to do for us is going to suspend that crop material, the lighter chaff and mog, and it's going to allow that heavier grain to get down onto the cleaning shoe and start to be processed through the cleaning shoe itself. So we've had great success with this. Like I mentioned, the sample quality as far as the cleanliness and as far as the cracks and splits in this design has been very impressive. Some of the results that we've got in field test are very enticing, especially looking at the competitive comparison. Some of the targets that we have, of course, are some of the bigger yellow combines when we look at grain quality. And from some of the studies that we've done, we've been very, very pleased with the results so far. So this will conclude our cleaning system. At this point, we can take a look at some of the questions that have arose during this section. So one of the first questions we had was in relation to the stratification pan. And the question that was brought up to our attention was, in case of cleaning, what is the process to clean the stratification pan? Maybe if we get some material bridged up on top of that pan, what's the process to go through and actually clean that pan itself?
I guess as far as that, really just letting the machine clean itself out and letting that machine run. You might get a little bit of buildup on there, but just letting the machine run wide open. Letting the machine run wide open with the processor on, that stratification pan will clean itself out. Now we do have the ability to open up our side processor doors, and you can scoop material out of there by hand if you want, blow it out with an air compressor. That's another way if you've got stubborn material that won't come off, but I, for instance, have not seen that in the field, seen an issue with that, but that is available if need be.
All right, thanks, Zach. So we had one additional question come up, and it was in relation to our rock trap. It was kind of an initial segment that we walked through, but the question was, we've had a couple of our dealers have the opportunity to run this in the prototype stage. And one of the questions was in relation to the rock trap, the position, the volume of that rock trap, and in specifically how effective it was in catching stones in that prototype stage. Now, we are currently running a new design. It is currently being validated as we speak in South America. So there will be more information that we can give you on that once we get that validation process done. But yes, we are working on a new rock trap design. It is currently being validated down in South America. Okay?
So moving forward into residue management, I wanted to show you guys by starting off, now that we just got done talking with the cleaning shoe, go into the chaff spreader, some adjustments for that, some things you can do with that in the field, and also a little bit of the relationship it has to the shoe. So as you can see here, our chaff spreader is oriented right behind our cleaning shoe, and a couple neat features about the chaff spreader just right from the beginning. So you can pull a pin on the right-hand side of the combine and swing that chaff spreader out for ease of access to the shoe, for pulling chaffer, for pulling sieve, and this is with our chopper towards the rear part of the combine, slid back towards the rear of the combine. So you could pull that bottom sieve without having to pull your chaffer out. That's a feature, just some of the room, some of the space that we have in here, some of the accessibility that we have. Now another few things about this chaff spreader. If you're running in some cereal crops and you guys are laying down windrows or whatever crop you might be running in where you want to lay a windrow, you can re-engage that pin on the right-hand side for the spreader, and you can pull this little lever and swing that spreader down. Now if you're like me, or a little bit more old-fashioned, or like some of the farmers out there, they just want to remove the spreader altogether. We can do that too. You remove the pin from the right-hand side, you remove this pivot pin, and we've got two hydraulic quick connectors here that you can take the hydraulic spreader completely off the machine if that's something that you want to do. Another couple cool features about this chaff spreader, as you notice, right now we have it oriented so that it's shooting that chaff right out directly to the edges of the combine, right behind this back tire. Now, depending on what application you're in, that might not be what you want to do. So by using this spring adjust pin right here and this handle where my right hand's at, pushing down on that pin and moving this spreader right here, you can lock it into position and do a second position. So we have that first position shooting out towards the edge of the combine. We have the second position here, and we can even move it in more narrow, pointing towards the chopper in our third position. So we have 3 available adjustments for our chaff spreaders for different applications. And actually, I'm going to turn this over to Brent because he's got a pretty good slide that shows the differences between each orientation and how they can be applied in the field.
All right, Zach, so thank you. As he mentioned, we have a couple of different options that we have available for our chaff spreaders. And what I like about this, it really meets the customer's requirements. We can really do anything that they ask of us in this example. So the top illustration here is where we'll actually take the material off of the shoe, direct it into the chopper, and we will spread the chaff and the rotor discharge material as one. So we will once again run the chaff through the chopper and spread it with the rest of the residue that comes off the rotors themselves. The second option is what we call the direct discharge into the center of the windrow. So you can adjust the chaff spreaders to basically deliver the chaff to the center of the windrow when you have the chopper rolled back and dropping a nice heavy windrow of straw. So some guys want to use this for the feed value. They want to have the chaff mixed into the windrow. This setting right here, as I mentioned, you'll have the chopper rolled back, you're dropping a windrow, and you're going to be delivering that chaff to the center of that windrow as it comes out the rear of the machine. The other option that we have available is to completely spread the chaff separate of the rotor discharge, chopper discharge rather. So this is once again giving our customers the opportunity to either spread the chaff through the chopper with the rest of the residue management system. We can drop a windrow, incorporate the chaff directly into that chopper discharge. And then the other thing that we have available is to completely separate the chaff from the system itself. You can do this when you're running with the chopper engaged, or you can even do this when dropping a windrow. So your windrow would be nice and clean, there would be no chaff within the system, and it would just be strictly straw for that baler to come and pick up. So as we mentioned, the direct discharge off the back of the processor, the chute that we were showing you on camera here before is illustrated in the top left image. So as the rotors discharge that material, they're going to come down into the direct discharge into our chopper. Now we do have a couple of options available on the straw choppers themselves. What's depicted right here is what we're going to call our base cut chopper. It's going to have 4 rows of knives. There's going to be 56 total knives on this chopper drum. And then in addition to that, we have a stationary knife bed. You can kind of see it pictured right here, up here in the top left image. There will be a total of 28 counter knives available to provide a very good chop quality, good residue management. But of course, there are those guys that find it very important to, once again, pulverize that crop, make it very small. You want to get a quick breakdown of that material and get a nice even chop and spread out the back of this tailboard after it goes through the chopper. So our other option that we have, this is once again our base cut option. The second option we have is our premium shortcut option. So rather than 4 rows of knives, we're going to incorporate 8 rows of knives. We're going to double the amount of chopper blades on it. We're going to go to 112 chopper knives on this drum. In addition to that, the counter knife bed that I mentioned here is going to once again, instead of having 28, we're going to nearly double that to 55 stationary knives that we have available for this. Now, when looking at options that we want to have incorporated on Ideal combines, it's very important to understand the needs of your customers. And what I would say, if you're running larger headers, you're probably going to want to be able to process that material a little bit finer and get a nice even residue spread out the back of that machine. So the shortcut option would definitely be something I'm pretty confident we're going to see a pretty high take rate on. Now when you're running in the Class 7, if you're running smaller headers, maybe residue management isn't as keen to that operator. Going to that base cut option, I think, would definitely serve its purpose for that grower. Let's move on back. So as we continue this transition from the discharge of the rotors into the chopper, the final piece to this story for the residue management is going to be our tailboard options. Now there are also 2 tailboard options available for the Ideal combine. On the left-hand side, we have what's called our passive tailboard. This has the ability to be manually adjusted on the back of the machine as a standard option, but we also have the capability to have electric actuators up here to adjust from the cab. So you can adjust your spread width based on the conditions that you see in the field, based on the header size that you have installed on the combine. The other option that we have is what we call active spread. This is going to be our premium option. It's pictured here on the right-hand side, and you can kind of see the dual spreader disc that we have incorporated into this design. It's going to be, once again, our premium option when you're running larger headers and you're needing to get a full spread, a full, nice, even spread of that residue. This grower is very keen on residue management, most likely going to be a no-till grower, this would be the option for him. Now what we're going to do, we're going to go and take a closer look at this design. I got Zach on the camera, and he's going to walk through how this is actually driven and some of the benefits that we have with this design itself.
Thanks, Brent. I'll walk through a few things here on the tailboard. First of all, a little bit about the adjustment of the tailboard. We have a pin here on the side, and we also have a pin on the other side for adjustment. So if you want to rotate that tailboard about the rear end, just to kind of get, as you're going through the field, whatever kind of spread you need for what your crop, however much engagement you need for this active spread, it's something that you'll see in the field. But I like to touch on the components of this active spread. So we got a hydraulic motor here running these spreaders. Nice thing about these spreaders is this hydraulic motors run off the chopper, so it's a proportional speed to what your chopper speed will be, and you can adjust that speed, or proportional flow, excuse me. You can adjust that speed from the cab, so that's pretty handy too. Another thing I want to highlight here is these electric actuators on top for the adjustment for the active spread. That's something like Brent mentioned before. If you got a grower and you're trying to spread up to 45, 50 feet, that can be pretty tough. So with the pitch and the placement of these fins and being able to adjust it from the cab, and then also being able to adjust the speed of these spreader discs from the cab, you can really cover that 45, 50-foot swath, whatever it is that you might be taking, 16 rows. Now, one thing I want to highlight too is what we call our active spread. It's controlled by what we also like to call our headland management. We'll talk about that in a little bit. In the technology, but right now Brent's got an animation that he wants to show you guys that'll highlight a little bit how our headland management works in the field and how our wind compensation also works in the field if you're going east and the wind's blowing out of the north.
All right, thanks, Zach. So, as he mentioned, we're going to walk through a quick animation of how active spread tailboard works. Now, some of the vanes that he walked through on the back there, as we mentioned, those are controlled from the cab. So there is an icon or a button on the right-hand console that allows us to go through and adjust the direction of our travel for those vanes. So the first thing I would tell you to do, we are from our combine in the top right corner, we went into our residue management screen here. And this is what you're going to see as you populate this screen. We're going to show our width, we're going to show our offset, and then we're going to show our chopper speed itself. Now, the unique thing about this, and just for your reference, when you are trying to set your width of your discharge, this is something that you're going to do by simply increasing or decreasing that width. You're going to show the active width, and I'll play this animation just to show what I'm talking about here. But you decrease and increase your active width, your active spread, by these two icons right here. Now, Zach kind of alluded to it. We have the capability then to compensate for wind. And that's something that we've never had in our combines today. And in a really heavy side wind, you can notice and you can see exactly where those machines were traveling in the field. You can see that the residue discharge is spread off to one side versus the other. And one of the things we wanted to do was be able to combat that. And what we've incorporated into the software is the ability to change the offset of our discharge. I'm going to play through this animation and keep continuing to talk through it, but we can adjust from side to side where our offset's going to be. Now, if we're going, let's say north-south, we got that side east wind, we're going to have to get that material adjusted over here to that right-hand side. So once I get the offset set correct and get it distributed over to that right-hand side, pressing this center button in the middle will then change that residue discharge from one offset to the other. What that would do for us then is in the example, if we are going to be turning around on that headland, I've had it over here, as you can see, on the far right-hand side. I press the center icon, it's going to go ahead and switch it over to the left-hand side. So after I turn around on that headland, that tailwind is going to be out of the other direction, and I need to get that adjusted. So this is the manual process in order to do that. You can see I'm going from the left-hand side now. It's going to slowly transition that discharge over to the right-hand side. This is something, to my knowledge, that's unique on the marketplace, and this is a feature that I'm really, really excited about. especially when talking to growers and how important residue management is in their operations. Even in adverse conditions, having the ability to spread evenly is something that I think is truly unique that you guys need to be able to go out and inform your customers about. So once again, with that active spread tailboard, the effective spread width up to 50 feet in ideal conditions. Once again, when we're in those adverse conditions, I would not safely spread that 50 feet, but you're going to get a very nice compensation for that wind when you're looking at that residue discharge out the back. One additional thing that is worth mentioning here when you look at the design of our tailboard versus the competition. Now these were from some lab test studies that were conducted over in Randers. But one of the things that we look at is the placement of our spreader discs compared to the competition. So this is, let's walk through this slide here. This is our chopper drum itself with our knives. This is our shortcut option. That material flow is going to be spread evenly throughout this chopper, and it's going to be processed through the vanes and through the spreader discs. Note the location of our spreader discs in relation to the choppers themselves. They're located towards the outer edge of that chopper. In essence, what this is doing for us is we're not going to have a lot of restriction of crop flow from the chopper throughout the rear of our tailboard. So some of the lab test studies that we did here was very impressive as far as the horsepower ratings ours took compared to the design that you see over here on the right. This would be of a competitive model. They once again had the larger chopper discharge just like us, but the large spreaders that they use are positioned directly in front of the crop flow from the chopper. So think about what the material flow would do in this example. The material flow, you have a high yielding crop, a lot of mog. Let's say we're running in some high yielding barley. We're cutting on the ground. We're taking in a lot of trash. What we're going to see then is we're going to see a lot of that material start to get restricted here on these spreaders. The material is also going to start spinning. The spreaders are spinning in like so. That material that's incorporated over here to the outside is going to have to be repositioned to run through the center of these spreaders. So there's a lot of crop congestion at this point. Now the horsepower in order to drive this design compared to ours was significant. We were looking in some cases in the lab studies that we did in that crop, in that condition, we were seeing up to 25% horsepower savings on our design versus some of the competitive designs. So really what that equates to, the spread itself between both of these, you're going to see a pretty even spread through the competitive design, but the benefits that you're going to get from our design is that horsepower savings. You're still going to maintain a beautiful spread pattern, but the horsepower savings is significant. We can equate that to a lot of things. We can equate that to fuel savings. We could also equate that to, hey, if I'm in a tougher threshing crop and I need some extra horsepower to push through this green slug, I have some extra horsepower compared to what that competitive design has. So once again, this is something that's unique in the design. It was designed this way for a reason, and we wanted you guys to be able to understand why we designed our tailboard the way we did. Okay, with that, we are now going to transition into the grain handling portion, but before we do that, understanding your time is very valuable, we are going to take a quick 15-minute break. This will give you guys the opportunity to make a phone call, answer some emails, get up and use the restroom, but more importantly, we would like to hear from you. If you would take the opportunity, spend maybe a couple minutes, 5 minutes, write us some questions. This is for you guys in the field. What we're doing here today, we want you to be informed. We want you to have the confidence to go out and talk to your customers. So if you do have questions, this would be the time to send them in to Caleb on the email or through the chat. And prior to beginning the grain handling session, we will go through those questions that you bring in during this break. So we will take a 15-minute break, and we will start right back up at 10:30 with the questions that you guys have for us in the field. taken care of some emails, some calls, got rejuvenated for the rest of this presentation. So we did have a couple questions come up. Thank you for asking them. We had a great couple questions come in, and one of the first ones was in relation to the shoe distribution. So we talked about how we take that material from the rotors, we incorporate it down onto our Ideal Balance cleaning system, our return pan system, and how that channels that material down to the stratification pan and keeps it nice and even. The question that arose was, after it comes off the stratification pan, how do we maintain that distribution onto the cleaning shoe itself, onto the chaffer and sieve? So as we drop the material off the stratification pan, we do have risers on that chaffer and sieve. So what that will do for us, as it comes off the stratification pan, it will find its home on that cleaning shoe. It will ride throughout the entire process on that exact area of the chaffer throughout the entire process. So I hope that answers your question. We do have the high-rise dividers, and we have some smaller ones as a standard offering, but you do have the opportunity to put the higher ones on, and that will channel that material throughout the entire process. So we did have a couple of other questions, and we're going to head right back to the back of the machine and let Zach take a couple of those.
So we had a first question about distribution to our chopper on the Class 7. So how do we get an even distribution? How do we distribute it to basically throughout the width of the chopper? So we have deflectors. You won't be able to see them on this machine, but we do, coming right off the rotor before the discharge chute, we do have deflectors that you can adjust from the inside there to help make sure you get even distribution to your chopper. You're not wearing one side, you're not spreading to one side, etc. We also had a question as well about the hydraulic hoses on the right, or on the left-hand side of the combine here. What do these hydraulic hoses do? So basically, I'll start out at the pump here. The pump is driven off of the chopper, and the pump is going to drive our spreader motors. So this hose right here is our supply for this pump. We're sending oil supply to our manifold, and that manifold is going to be able to control the speed of our spreader motors. Now this other big hose that comes back around and goes back up to our tank, that's just going to be our return line. So I hope that answered your guys' question for that. If you guys have any more, keep on asking. I think we're going to take it back to Brent as well. He's going to address a few things that were also asked in the breakout portion.
Okay, thanks, Zach. So one final question that we had come in, and once again, if you have more, please keep them coming. The other question was in relation to the slide deck, to the presentation that we're going through today. Will you guys out in the field have access to that? And absolutely 100% yes. We want you to have the reference material. We want you to have the specifications of this machine so you can confidently go out and speak to your customers. As far as a time frame on that, we'll send a communication out after the call of when you can expect those slides and the presentation that you're viewing here today. So with that, we're going to continue on, and we're going to talk about our massive grain tank system that we have on this combine and the sheer speed that we can achieve with this machine itself. So with that, we're going to transition to our two options that we have available on the combine. The first option that we have is called our Streamer 4.0. And the second option we have is our Streamer 6.0. So this slide will go through a comparison of the two designs themselves. Some of the key things we'll talk about here is the sheer volume of the grain tank. This is our Streamer 4.0 on the left-hand side, and this is the Streamer 6.0 on the right-hand side. Some of the things you'll notice are the cross augers in the tank on the Streamer 4.0. We only have one. You come over to the Streamer 6.0, we're going to have two. In addition to that, we can look at the drives. The drives to run just a single cross auger versus the drives to run dual cross augers in the tank. We'll break down each of these a little bit further as we continue on. So the Streamer 4.0 is going to be our base option. This is going to be commonly configured on the Class 7, but you do have the option on a Class 7 machine to upgrade to the Streamer 6.0. The specs on this Streamer 4.0, however, is 350 bushel grain tank with an unload rate of 4 bushel per second average. That matches what we have today as the peak rate in the combine industry. So we match that with our axial and gleaner combines. We're going to maintain our current unload rate with the Streamer 4.0. Now, this did go to a different design than what we have today in our combines as well, and we need to be able to talk through that. The design we've gone to is the turret style design. There's a couple of things that we can benefit from this system. One of the main things that we have got hit on in the past when looking at our gleaner design or our axial design is the fact that we have no capability to swing that unloading auger during the unload cycle. This would give us the opportunity to top off a cart or semi and get better visibility of this unloading auger during that unload process. So that's one of the designs that we went to, but how do we do it different than the competition? How are we better with our turret design than what other guys do out on the market? So one of our key things that we wanted to do with this turret design is maintain optimum grain quality. Now, it's very important for a lot of growers to not have damage to the seed. Anytime you incorporate a mechanical action onto that seed, it has a chance to get damaged. So we have a slow transmission speed. The gearbox on this is very slow transmission speed. We've done a lot of work with the flighting and the pitch of this auger in order to move an exceptional amount of grain. In the turret itself, the design is very robust. It is a large boot. The maintenance concerns that you have with some competitive designs, you will not see any of that with this design. We've had quite a few hours on this machine, and this has not been an issue at all. A lot of the lab tests we've seen has also provided really good results. So just a quick summary on the 4.0, it'd be a 350 bushel grain tank and that unload rate of 4.0 bushel per second. We'll transition into the Streamer 6.0. This will offer the largest grain tank on the market today. It'll be at a massive 485 bushels in the tank. Once again, this is an option that can be available on a Class 7 machine or the Class 8 or Class 9. So across the board in the industry today, this will be the largest grain tank. And let's talk about unload speed. The fastest thing that we have in the market today is going to be that peak of 4.5 bushel per second. We're going to average 6 bushel per second unloading out of this 485 bushel grain tank. I was running out in Illinois in some high yielding corn and started with a completely full grain tank unloading into the grain cart. By the time we continued harvesting and unloading into that cart, we had over 600 bushels that landed into that cart. This is a very fast, a very large volume grain tank, and it's something that I am very excited about. To have this option on a Class 7 through Class 9 machine is fantastic. Now, some of the neat things about this design too is the fact that our transmission speed to drive this auger is actually slower on the 6.0 than it is on the 4.0. So we're turning these augers slower, but we're moving more grain. And how do we do that? Sheer size, the pitch of the flights, this is really where we're going to gain that benefit. And the ability to have 2 cross augers in the bottom of that tank. The key thing to mention here is even though we're unloading faster, we're still not going to damage that grain that you can see in some competitive turret style designs. One other thing that we want to talk about before we transition up to Zach in the grain tank itself is going to be what we call streamer gates. Now, streamer gates are unique to our combine as well, as far as something we've never offered today. But pay attention up here to the unloading auger itself. You're going to notice that our gates are opening and closing. Now, we're controlling that down here on the right-hand console. So on the back right-hand side, the blue buttons that we have available, they're highlighted with the red arrow. You can decrease your streamer gates or you can increase your streamer gates. Now, this is going to directly control the volume of grain that enters into your unloading auger. One thing to keep in mind is as we've gone through this, our unloading auger has been disengaged at this point, so we're strictly showing silhouettes. But if we continue playing this video, you're going to notice that they turn on green. So at this point, we have engaged our unloading system, and at that point, we're unloading full. Now we're half, now we're down to a quarter rate, and now we're at the slowest rate possible. And you can increase and decrease this on the fly. Now, one of the advantages of these streamer gates and some of the questions that we've had in the past on our current designs is how can I clean out my unloading auger if I'm not able to completely empty it out? The concern comes when I'm folding and unfolding my unloading auger with the full load of very high yielding, really wet corn. It's a lot of weight suspended out there. How can we make sure that that stays clean? So we're not going to damage the drives, the shielding on the side frame, any of the hydraulic components. One of the nice things about this design is the fact that when you engage your processor or your unloading auger rather, excuse me. When you engage the unloading auger, the streamer gates will go to the set point that the operator has designated. In this example, we are set currently at full stream. So it will go from closed to full stream. Now when disengaging, built into the software, the streamer gates will automatically close down at the end of that unload cycle. What this will do for us is it's going to make sure that our unloading auger is going to remain with a very light load inside of it. There will be some material inside of the unloading auger yet, but it will be a very, very minimal amount. So when looking at the startup engagement, looking at the horsepower that it takes to engage an auger when it's full of heavy wet corn, you guys know as well as I do how much torque that requires and how that could potentially damage our drives. Now there is a shear bolt system on this combine as well. It's located on the right-hand side of the machine. So for any case that it does happen, we do have that protection built into the system. With that, I want you guys to take an actual look at the grain tank up in the tank itself. I threw Zach up in there. He's going to walk through these streamer gates and show you some of the benefits and how they actually work.
So guys, look over here in the actual grain tank. It's a 485 bushel grain tank, the 6.0 streamer system. And we've been talking about these streamer gates the whole time, but we want to kind of show you what these mechanisms, what these devices are, and how they're controlled inside the tank. So you see these shields, these sheets right here, and this adjustment arm. So basically, as Brent mentioned before, when you disengage your unloader, these gates are going to go down right away automatically, and so that your cross augers can clean out, especially when you get in that wet corn. So when startup comes back around, you're not going to have 2 augers full of wet corn with all this grain on top of it. It saves the life of our drives, it saves the life of our augers. It also improves our efficiency and decreases the power that we need on unload startup. So as Brent showed you, those little boxes on the auger on the terminal, you can highlight those in 1, 2, 3, or 4, and basically that's going to adjust how far this gate and this gate, how far they come up. So 1, come up to about here, 2, 3, and 4, right to the top. And so right now, this is what it's going to look like when your unloader's disengaged. Those gates are all the way down. So they're not completely closed, but they're pretty darn well near. There's just a little bit of grain getting in there. So these are hydraulically controlled. There's a hydraulic cylinder that controls this mechanism arm. And basically what happens is when that cylinder's engaged, it pivots this arm and this mechanism, and these 2 arms move these gates up, and then when disengaged, that hydraulic cylinder is pressured the opposite way, and that mechanism goes back down. As far as a few other things to key on while I'm up here in the grain bin, I'd like to talk about these service steps as far as me getting in, getting out. As far as myself and Brent and the other percentile guys, these steps are really nice, really handy to get in and out. We'd also like to talk a little bit about these bin fill sensors. There's 2 bin fill sensors here located. Also with our big bubble up auger that helps improve our capacity. We can push a lot of grain and really help keep this grain tank full. And also be able to just hold the capacity of our clean grain elevator and the capacity of the large rotors and cleaning shoe of this combine. So with that, I'd like to move outside the grain tank here. Pardon me. And down onto the catwalk. And I invite you guys all to come down and join me, if you would. I'd like to talk about as we flow through our auger, as we're unloading this grain, you get to the end of your cycle, and you always have that little bit of grain dribbling out the end. And you're going out through the field, and it looks kind of bad when you've got corn or whatever, soybeans, wheat, whatever you got coming out the end of the auger. We have integrated into our design, into our screech belt, when that cylinder is activated, when that cylinder is engaged, we also engage a hydraulic spill saver. So on the end of the auger, you guys can see a cylinder, and inside that boot, we have a spill saver to help keep that dribble from happening out the end of your auger. One, we're not wasting so much grain, and two, it honestly just does not look well when you're driving through the field and you got grain leaking out the end there. So that basically will cover the grain handling system for our combine. We'd like to move on to engine specs and how we drive this combine and what the differences are between our class sizes. So I'll switch on over to Brent. We'll talk a little bit about specs and what we offer between the class 7, 8, and 9 combine.
All right, thanks, Zach. And as we mentioned, there's a lot of great features on this unloading system. As far as the sheer volume, the sheer speed that we can unload this, and then some of the simple things that our engineers thought about as far as an effective spill saver that's hydraulically controlled. Once again, as Zach alluded to, it's going to really fix the issue. It's going to work as intended. It's going to stop the grain dribble, some of the issues we've seen in the past with just a spring-loaded design. So once again, that's a great system, something that we will definitely be able to talk to our customers about when we invite them out to the Ideal Elite and the field events. So let's transition into the engine. Now, once again, some of the things that are unique to the Ideal Combine, when some of the things we've never had before when talking to customers, is a large differentiation between class sizes. So let's walk through an example of like a 9545 and a 9565. As you are aware, those machines are identical as far as components go, and the engine software is what's different. Now, what's unique about the Ideal Combine is we truly have different engines for each class size, and they're built to perform for that class size very, very well. The first one that we can talk about is going to be our Class 7 machine. It's going to be this first column. So the top here, the top row is going to show our standard rated horsepower. We're going to look at boost horsepower, and then we're going to look at the maximum horsepower that we have available at the top of that curve. So at 1900 RPM, that's going to be our rated speed for all the combines. That's where the combine will operate. The Class 7 machine is going to feature a 9.8 liter AGCO powered engine. That's going to be identical to what we offer today in our Massey combines and our Gleaner S9 combines in the Class 7 and 8. Now, our programming, of course, has changed a little bit on this 9.8 liter. Notice that we're only running it at 1900 RPM, so it's not truly the same. It does have a lot of different tuning and a lot of different parameters that are built into that engine itself. The rated power is going to be at 392 horse with that max power up to 451 horsepower. One thing to keep in mind when we're looking at our class sizes, with the Ideal Combine, we are going to be stacked very, very well in each of these class sizes. We're going to have a high-rated horsepower on the Class 7, the Class 8, and the Class 9 machines. So that is exactly where we want to be. We're going to have high performers in each one of those class sizes. Now, one of the things that we have introduced different on our Class 8 and Class 9 model is the use of a MAN engine. So the MAN engine is common within AGCO today. It's the same engine that we use in our Challenger 1000 series. And for those of you that have ran that particular piece of equipment, you can understand the benefits of what that engine can offer and the technology that goes into that engine. So on the Class 8, we'll feature a 12.4 liter MAN engine rated at 470 horsepower. Once again, it's going to be rated at 1900 RPM for the engine speed. The max power available that we have on that 12.4 liter is going to be up to 538 horsepower. So once again, in a Class 8 combine, having that horsepower availability is fantastic. We're going to be stacked very, very well against the competition in horsepower ratings. The Class 9 is our final offering that we have, and that's going to feature a 15.2 liter MAN engine. So when looking at the specs here, the standard horsepower on a Class 9 combine is going to be at 564 horsepower. When we look at that max power curve, we're going to be up to nearly 650 horsepower. It's rated at 647 on the max power. So when looking at what your customers are going to need, what they're going to see in their harvest operations as far as field conditions, hilly terrain, and the other thing to look at is some of the things we'll talk about later is tire configuration. The tracks that you've seen on the walk-around video versus a wheeled machine and the horsepower that it takes to drive that, and as you know, it's going to take a little bit more. So having a little bit more available horsepower for that operator when he goes up to that Class 8 or Class 9, that's something that'll be your job to determine what size of machine that he needs. And the key thing to keep in mind is there are going to be true differentiations between each of these class sizes. It's not going to be the same skeleton with different horsepower ratings. And we've walked through a couple of these already, but this is just one more that you would add to the list. I've got Zach up on the back of the engine deck yet, and there on this slide you can still see that there is a AirSense cooling package that we have on top of the engine. It's directly coupled to the engine. Now I'm going to let Zach walk through that. He got the live camera feed and kind of share some of that design and how it works so well out in the field.
Thanks, Brent. So we are calling this cooling package the AirSense cooling, and I believe the best way to describe to you guys how this works is to break it down into two portions. So first I'll explain the cooling part, where we're getting our air from, and then I'll kind of dive into the AirSense portion and what that all entails. So on the top, on the right hand side, we have this screen, and we're going to get our most clean air from the top of the combine. That's where we're going to be able to suction in, get clean air instead of coming from the side of the combine. That keeps us from having a rotary screen cleaner. So we're going to pull that air through our cooling package, and we're going to use a fan, a 47-inch diameter fan, to blow that cool air across the engine and across some of our hydraulics as well. So one thing that gives us a high amount of volume of air that we're pushing across the engine, we're really going to be able to move a good amount of air and keep this engine cool. Now the AirSense portion of this engine that we find really cool is the AirSense basically ties into the fan pitch. Now your fan pitch is going to be adjusted based on what your engine temperature is. So if you're in cooler conditions and you're seeing maybe lower engine temperatures, you're going to be able to, it's automatically going to change the pitch of those fan blades so that you're not drawing as much horsepower. It's going to make that pitch a little bit less. So when you're not needing to push all that air across, we're not going to be pushing that air. The temperature is basically changing what the pitch of your fan blades are doing. Now, with the screen that I mentioned before, we're going to accumulate chaff and dust and dirt and debris on that. So built into the AirSense cooling, I mentioned earlier that we could change the pitch. Well, we can also reverse the pitch. So basically, when we reverse that pitch, we blow air back through the system, and we blow all that dirt and chaff and debris off the top of that screen off to the right-hand side of the combine. Now, that'll actuate automatically every 15 minutes. But also that is based off of engine temperature. So say you're out, it's 100 degrees plus, getting a lot of chaff and debris on there, and it's been 7 minutes, 10 minutes, 11 minutes, anytime inside that 15-minute cycle, and it senses that your engine needs to see more airflow coming through, it'll automatically reverse the pitch of that fan and blow all that debris off the top and blow that down to the right-hand side of the combine, and then it'll adjust the pitch back to where it needs to be to push airflow across the engine. So a pretty efficient way to keep our system cool. We also have manual reverse. If you're at the end of the day, this could be kind of a service item. You're getting ready to shut down your machine. If you want to manually reverse to blow that screen off, you don't have to come up here with the air hose every day and clean out your screen and clean things off up here. So that's another handy portion on the service side. Now that I'm talking about the service side, I'd like to walk you guys through just real quick a couple features about our DEF tank and our fuel tank. So our fill ports are right here. You see what would be on your guys' left is our DEF fill, and our diesel fill. On your guys' right is going to be our DEF fill. So we have these clearly marked and labeled so that any operator that comes here in the morning or at the end of the day doesn't get these two confused. Also, it's nicely accessible from the ladder. And having it on the rear side of the combine, you could swing your service truck in here at the end of the day in the morning, or if you're backing up to the fuel barrels in the yard at the end of the day, it's easy to swing the rear end of this combine up next to them and get filled up. The nice thing is, you can reach them from up here on the deck. You could also reach them from the ladder, and not having a large volume of space between these fill points and the back of the combine really helps you get as close as you can if you don't have such long hoses on your fill tanks and whatnot. So now that I've covered a little bit of that serviceability portion, I'd like to shift it back to Brent as we talk about some options that we have as far as tank volumes between Class 7, 8, and 9 machines.
All right, thanks, Zach. So once again, this is a little bit of a change for us compared to what we've had on our machines before. So we've relocated our tanks to the back like Zach displayed. They're going to be located right next to each other. And what we're going to walk through next are just some of the volumes that we have available for the DEF and fuel tanks. So this chart down here in the bottom right corner is going to highlight what's standard, which is highlighted in black, and what's optional, which is a open, just an outline of a box. So let's walk through these examples here. The Class 7 will come standard with a 264-gallon tank, and it will have the option to upgrade to a 330-gallon tank. The 264-gallon tank is only available on the Class 7. You can see as we transition to the Class 8 that 264-gallon is not an option. The 330-gallon tank will be standard on the Class 8 offering, and will have the option to upgrade to a 396-gallon tank. Same way with the Class 9. It's going to be identical to the Class 8. The 264-gallon is not available on the Class 9. Standard with the 330-gallon tank and the option to install a 396-gallon tank. And when looking at how that stacks up against the competition, we are offering the largest tanks in the market today as far as the sheer gallon volume that we have. So once again, looking at operators that are keen on capacity, one of the things that I want to share with you is the fact that if we can run all day and we can run into the night, early morning, and not have to stop to fuel, that's only going to improve that capacity. That's less downtime that operator has to shut the machine off, pull the truck up, and refuel. So having that option available to upgrade on the Class 7 to that 330, and then of course up to the almost 400-gallon tank on the Class 8 and 9, should provide our customers that ability to go all day, even when pushing that combine at its limits. Now, Zach mentioned a couple of things that I thought were pretty important when we talked about our AirSense cooling package. And for those of you that are familiar with the FlexAir fan that we have on our Gleaner combine, that FlexAir fan is exactly what we're using on the Ideal combine. It virtually eliminates the need to service that radiator. But let's say, for example, you wanted to blow off your combine. You wanted to clean it up. There is a really neat feature that we have as an option available on the Ideal combine. And I've got Zach down on the ground again at the back corner of the machine, and he's going to walk you through what I'm talking about and alluding to.
So one thing we want to highlight as an accessory item, also for serviceability on this machine, is our onboard air. So we have a 20-gallon onboard air tank, and we also have 2 pressure ports around the combine for ease of use and ease of accessibility. So we have one of these ports right here below the actual tank itself. So if you want to blow off the engine deck, you want to blow off this side of the combine, whatever it may be, you want to blow off stuff back here. If you want to blow off inside the shoe, that's a really good access point for that. Now, if you come with me around this side of the machine, I'll show you guys where your air hose is actually located. So you've got a 30-foot air hose and air nozzle with this machine. Your air nozzle's located inside your toolbox, and you've got an air hose, right next to your toolbox here as well. So we kept it wrapped up real nice. We got a keeper on here, and also a little Velcro strap to keep this from flailing around and ending up on the ground. And so that's a nice little feature. We also have one more pressure port on the front side of this machine on what we call our serviceability dock. So you'll see up here on front, we have 5 grease zerks, or excuse me, 6 grease zerks. We also have another pressure access point for our air compressor right here. So if you need to blow out the inside of the cab, we know how dirty the inside of the cab can be, on top of the feeder house, even things on your header. We have that availability right here. So I want to highlight once again, you can take this 30-foot hose with you all around the combine. It comes right off these 2 keepers right here. You can take it to the front, to the back, blow off wherever you need. And actually, while I'm here, I would like to highlight something else that's unique to this combine, and something that's really neat design, and we're going to dive into this a little bit more. So up above me, up above this tailings auger, you're going to see the drive center gearbox. We call this a drive center gearbox because it's mounted right off the engine, so it's taking engine power and it is transmitting it all throughout the machine. So what you'll see here is we have different outputs on the gearbox, and the inside gears of this gearbox are self-lubricated. So basically the gears on the inside of the gearbox are in an oil bath. And so once those gears turn, they just lubricate themselves like most transmissions do. We also have some wet clutches on this gearbox that engage our header drive, that engage our main separator drive. And so those wet clutches are also lubed in a different way. We have a separate lubrication system, and this is all internal within that gearbox. So it's pulling supply oil from that oil bath, from the internal gears, and it's using a pump, a manifold, and an internal filter to lubricate these wet clutches throughout this drive center gearbox. So now that I've touched on that a little bit, let's dive in a little bit deeper into all the outputs and the power transfer throughout this combine. Brent, would you like to take us away?
Yes, sir. Thank you, Zach. So as Zach mentioned, we were referring to the drive center gearbox, which is really the heart and soul of all of the drives on this combine. What we were alluding to is the image that you see on your presentation now. This is the drive center gearbox. It's directly coupled to the engine. The drives we'll walk through all of these through a series of animations to clearly show you how this machine is driven and show you the benefits and some of the design enhancements that we have in order to make a very efficient power transfer to each of our drives that we have highlighted here. So the first one that we'll talk about is going to be our header drive. It's driven off the front of the drive center gearbox. So as we zoom in on this animation, you're going to see there's going to be an input shaft right here that's going to be coupled to a variator. So when we talked about our feeder reverser at the beginning of this presentation, this is our upper header drive gearbox. We do have multiple options available for our header drive gearboxes. So looking at the standard 135 kilowatts, going to run everything that we need from a 25 up to a 35-foot header. Now, we also have the opportunity to install a 220 kilowatt drive box up here at the top, the upper header drive. What that is going to allow us to do when we move into a grower that's keen on that capacity, wants to run larger headers, we have the options available to run up to 16-row chopping corn heads, and we also have the ability then to run those larger platform headers if we're looking at a 45 or 50-foot offering that's out on the market today. So we do have multiple options, once again, available to meet the needs of our customers. So from that drive center gearbox, we're going to transfer that power through a belt down to our upper header drive. And we're going to have one long drive shaft that will come down and transfer power from our upper header drive down to our lower header drive. Now, not to confuse you, but there are multiple options available as well for the lower header drive, and we'll dive into those here a little bit later. As we transfer power through that lower header drive gearbox, we're going to couple it with a U-joint to our front counter shaft drive, and this will then drive our feed conveyors. Now, what we have pictured here is a 2-speed option on our feed conveyor. This would primarily be used down here in the States when we're running in corn, soybean applications where we would like to slow down that drive in corn and speed it back up in our soybean application. For our growers up in Canada, primarily what we're seeing up there is going to be a fixed speed header drive. So this would not have the multiple belts that you have shown here. It would just be one single drive that would be available for the conveyor. Now, just to put this into perspective, what this is going to drive then is going to be our feeder chain group. And what we have pictured here is the Class 9 4-strand feed chain. So just to bring this full circle from that drive center gearbox off of this front sheave, transfer through the belt, through our drive shaft down to our lower header drive gearbox. We'll couple that power directly over to our feed conveyor drive, and that's what's driving our feeder chain system. The next thing we're going to highlight is our cleaning fan. So once again, off of that front input on the drive center gearbox, we're going to go down, and the thing with the hydraulic fan is it's actually not mechanically driven with any of these systems. It is hydraulically driven. So one thing to keep in mind when looking at cleaning fan and some of the designs that we've had over the past in our axial design, we've actually gone to a hydraulically driven fan in our current Massey and Challenger combines in the axial. So we'll maintain that hydraulically driven fan. It gives us the ability on the fly to get great response out of this system for fine-tuning the fan itself on the settings that we want to achieve. And once again, hydraulically driven through this motor with a sheave on the backside to run a 2-strand belt down to our cleaning fan that we discussed earlier during that cleaning module. So once again, very simple, very robust, high performance on that cleaning fan as far as the cleaning capacity that we need to see in some high mog crops. As we transition, we're going to go right back to this drive center gearbox. Note, we are now moving out of that front output shaft, and we're going to go directly off, not the large pulley on the outside, that goes to the rotor drive. There's another sheave on the inside of this larger sheave that will drive our mid countershaft. As I continue this animation, you're going to see this 2-strand belt that comes down from the inside of that sheave. 2-strand belt will go through our countershaft, and this drive right here is what we're going to call our primary elevator drive. So a simple 2-belt design system here that's going to go over and drive our primary elevator drive. That will get transferred through a stub shaft to our secondary elevator drive. Our secondary elevator drive is a 3-strand belt. You can see it's got the automatic tensioning on the side here through the spring tensioner. And what that's going to do, in essence, is going to come up and drive the top of our elevator head to run the elevator chain. This pulley is an important one to note next. Driven off of this secondary drive is this pulley is going to have our U-joint coupled to it, and that will run our bend fill auger. Okay, just a quick recap. We got our 2-strand belt through our counter shaft to the primary clean grain elevator drive, which is a 2-strand belt. We're going to transfer that power through this little stub shaft to our secondary elevator drive. That will come up and run our elevator chain. In addition, we will couple that with the U-joint to run the bend fill auger. So once again, looking at the side of this combine, you're going to see more drives than what we're used to, just to be completely honest. But what we're walking through now is how simplistic this truly is when looking at these animations. So the one drive off the mid counter shaft is the clean grain elevator. That's what we just walked through. The next one that's actually coupled down below here is going to be our shoe drive. So once again, right off of that mid counter shaft, we'll couple it with the 2-strand belt. That's going to come up to our pitman arms up at the front of the cleaning shoe. And as you can see, then this is what's going to drive that shoe frame and shake this frame back and forth to help stratify and separate material through the cleaning system. So once again, a very simplistic design as far as utilizing that mid counter shaft for 2 drives. But one other thing to mention, after the shoe drive, as it comes down, this bottom pulley is also an important drive for us. As we continue this animation, you're going to see that there's a slip clutch on it. And Zach alluded to this a little bit earlier when we talked about our returns drive. It's driven off that right-hand side. And this is exactly where our return drive is driven. Right off of this mid-counter shaft down to this pulley with the slip clutch. You can see we've got our horizontal auger down through the bottom of the trough for our returns. I want to once again keep in mind that any material that comes off the back of that bottom sieve is going to run through a slide down to this initial cross auger. From there, we have our gearbox that's going to transfer that power to our vertical auger. And this is once again another illustration of how this truly works. So we transition that grain up the auger, and you can see the paddle design that we have to incorporate that material back to the shoe. Now, as Zach covered, we have a couple of different options available here as far as how aggressive we would like to be with our threshing. If we want to be more aggressive, we have the plate with the raised bars on it that can give you a little bit extra threshing in that small grain crop that's got a lot of white caps in the sample. This would be something you would have an opportunity to increase the threshing. Or if you're in an edible bean, perhaps, and you want to really focus on your grain quality, removing that cover with the grates on it and going to the smooth cover will really help out on that grain quality itself. Now, we mentioned this does not return to the processor, and where this is going to return to is going to be to our cleaning shoe. We showed that in the illustration earlier, the animation earlier. We're going to incorporate the returns right back to the Ideal Balance cleaning shoe to be processed again down on the chaffer and sieve. So the next drive that we'll talk about is going to be our rotor drive. This is going to be transferred from the large sheave on the front of the drive center gearbox. So the mid countershaft was ran on the smaller pulley on the inside of the larger sheave. We're now going to run a 5 HP belt to the rear countershaft of the combine. You can see we're transferring that power from the drive center to what we call our rear countershaft right here. And from there, we're going to connect with another belt directly in line, and we're going to go down to our variable speed gearbox for our rotor drive. So there is a variator directly onto this gearbox, and from the gearbox, it's going to couple to our highlighted shafts. Now, these shafts are going to go through 2 gearboxes that are going to directly couple to our dual helix or single helix rotors. So this is a mechanically belt-driven design with the ability to vary the speed on that gearbox through a simple variator that we've used in the past on several different drives. There are options available for a single speed gearbox and a dual speed gearbox. And I did remove the handle on it, but that lever is right here. That will be accessible down on the side of the machine, but you do have the capability to run this gearbox in a high or low speed configuration. Okay, so as I mentioned, the 5 HP belt goes to our rear countershaft first, and that's what's highlighted right here in this next animation. So what do we drive off of that rear countershaft? The main drive that we have off of that is going to be our chopper drive. So once again, a mechanically driven design on this with a simple 3 HP belt that we run off of that rear countershaft. And in order to change the speeds on this drive, it's very simple to do. And one of the things that we haven't showed you yet is the ability to roll that chopper back. And how we do that today on our combines, if we reference our axial combine, is going to be through a rack and pinion setup where the operator is required to use a handle to move that chopper rearward. Now, one of the things that is we're required to do that in order to detension the chopper drive belt. Standard on all Ideal combines will be an electrically actuated chopper housing. So rather than using the rack and pinion setup that we're used to with the handle, it will be electrically actuated on the back left-hand side of the machine to where the operator can move the chopper rearward and detension this belt. And then the simple requirement to go from high speed, which is shown here, to a low speed would be to slide the chopper about 3/4 of the way back in its travel. And then if needed, you can climb up the accessibility ladder on the back right-hand side and move this from the top sheave down to the bottom sheave and reroute it down on the bottom side as well. So once again, the crop changeover for this is it's very easy to do. There's not a lot of effort that's needed in order to get this chopper drive changed over. And for us in the States, running in the corn, soybean field multiple times in a day, maybe starting off in corn, then going to beans, and then back to corn. Having the ability to change this drive very, very easy without the requirement of tools or any other special tools as far as the handle, this is something that's a big improvement for us in the combine market here. We're going to transfer back from that 5 HP belt where we drove our rotors through our variable speed gearbox here. We transfer that power through these shafts. We did incorporate another shaft out the right-hand side rotor gearbox. And you can see it highlighted here. We have a shiv that runs a 2 HP belt. And this is going to transfer power all the way up to the front of the combine. And this is going to drive our rotor feeder. Now, one thing to keep in mind, one of the biggest benefits that I feel we have with this design is the fact that the speed of our rotor feeder is proportional to the rotors themselves. The way we're able to do that is as Zach mentioned in the previous, we've basically slowed the speed down of this drive to 70% of the target drive that we have here on our dual helix rotors. We've done that through a series of pulleys and reductions. So anytime that a speed is changed on our dual helix rotor setup that we have here, that speed is going to get transferred through here. So it's a direct relationship of speed, change of the rotors, that will be transferred down here to this front rotor feeder. The final drive that we'll be able to mention, we've gone off the front of the gearbox, we've gone off the side here, and we've also gone off the rear. But there is one additional drive to highlight, and that's on the inside of that drive center gearbox. And this will be our unloading auger drive for our either Streamer 6.0 or our Streamer 4.0. Once again, driven off the inside of that drive center gearbox, we're going to transfer power, and it's going to transfer down to a stub shaft down here at the bottom. And that's going to transfer power through, and that's going to run our cross augers. So not only is this driving our vertical auger, it's going to transfer power through, and it's going to drive both of our cross augers that we have available here in that Streamer 6.0 system. So the grain will travel up and through and out the tube to make for a very, once again, it's robust. It's designed to last for a very long time. We're not going to see a lot of maintenance out of this drive system, but the key thing to keep in mind is how efficient we're able to transfer that power through that 3 HP belt off the drive center, in line to our gearbox for the vertical auger, and once again coupling that power to drive our augers. We are very, very efficient in how we drive our major components on this combine. With that, we will transfer on into our next section, which will be ground drives. Now, one thing to keep in mind when we look at our ground drives, there's going to be a couple of things we walk through, and those are going to be the tire offerings that we have available on the machine. And what we're going to do is just walk through some of those offerings that we have. We'll dive into these a little bit in further depth here shortly. But we're going to walk through the tire offerings that are available on the Ideal 7, 8, and 9 models. The first ones we'll look at are our wheel offerings. So we do have multi-brand strategy here as far as the tire offerings that we have with the Michelin's, Firestones, Mitas. The duals that we have available are going to be a 520 85 42, the 620 70 R42, and then we have a massive 710 70 R42. Now, really what we're looking at doing here and offering these sizes of duals is looking at the requests from our customers and delivering tire packages that are going to have the least amount of compaction for their operation. In addition to that, it could be in muddy conditions where higher flotation is needed. So having that 710, it is a very, very wide footprint, not only for traveling down the road, but once again, looking at that gross flat plate that we have on the ground soil itself. That 710 is going to offer the least amount of compaction out of these three offerings that I just went through. We will also offer single wheels. So we have the 870 38s or the 32s. In addition, we have the 960 R38 and R32 tire offerings. So very similar to what we offer today, we're going to be very competitive on the offerings that are out there in the market. On the rear, we'll do similar to what we have today as well, a 520, a 620, and then the larger 750 rear tire offering to once again offer that flotation, that least amount of compaction possible in this combine. Talking about compaction has been a key component to a lot of the growers that I speak to and what a lot of us as dealer salesmen speak to. So what can we do to eliminate or try to even reduce that amount of compaction that we have? And what we're alluding to here is ability to have tracks. We've talked about them a little bit already. Caleb alluded to them and being designed in Jackson. And the ability to run a 26-inch, a 30-inch, and a 36-inch track. I would say this is going to be dependent on the class size and probably about the bin size that a grower does decide to have on his combine. One of the unique things about our 26-inch track is each of these tracks require a different wheel spacer on the front axle. So if using a 30-inch wheel spacer on a 26-inch track, that gives us the opportunity as operators to drive directly between the 30-inch space corn rows to eliminate any of the track damage that you see and to keep that stock standing. I know it's really important, even down here in Kansas, to maintain that ground soil moisture, and whatever we can do to keep that stock standing, to catch any snow blowing during the off season, to help build that subsoil moisture, that's something that we want to try to promote. So having that 30-inch spaced block on the front axle running a 26-inch track will give our growers the opportunity to stay between the rows, to eliminate that damage that you see on the tracks, and to keep that stock standing. I think this is a perfect segue. Let's dive in a little bit closer, Zach, on our track design and how well this performs and how Jackson has done such a great job on keeping that ride comfortable.
So that's a good point you made, Brent, about Jackson and the design of these tracks. So one thing I want to highlight about these tracks compared to the tracks that you'll see in some of our other Challenger Series tractors is we're going to see about a 60% similarity between components in these tracks and the tracks you'll see on the track tractors. I know it's a little bit different design with our center drive hub up here. But these things are beefy, these things are sturdy, and I want to dive into a little bit about serviceability of these tracks. So we really don't have to cover a whole lot on serviceability, which is the cool part. All these bearings for the hubs are what we call sealed bearings, and they're in their own oil bath. So basically, all the serviceability and all the maintenance for these are just going and making sure there's oil in the sight glass. And you can reference your operator's manual for levels on that and filling and all that good stuff. But I like to also cover some of our offerings for the 26 and the 30 and the 36-inch track. So like Brent mentioned before, our 26-inch track with a 30-inch spacer will get you in between those rows, and the 30-inch track will also get in between those rows. You might just have a little bit of damage on the outside of your tracks, or not damage, a little bit more wear, so to say. But that might be a better option for the guys that are running Class 8s, Class 9s with the big bins. What I really want to touch on here are these accumulators. You see one here, and we have another one right over here, and we also have two cylinders. Now the points of these two cylinders, the front cylinder is strictly just a tensioning cylinder. So we want to keep that track tension, because if we're slipping, we're going to wear out the insides of the track. We're not going to get the traction in the field that we need. We're going to waste a lot of power. Now our rear cylinder is strictly for suspension, but also helps support in tensioning as well. So we still have to tension up both of these cylinders to system pressure, which is about 3,000 psi. The cool thing about having directly inline accumulators is it helps offer a really smooth ride. So these accumulators are going to help absorb a lot of hits you'll see in the field going across a pivot track, going across a terrace, whatever it may be, going into a field drive. But also we're going to be able to absorb that hit and keep tension on the tracks so we don't lose traction as we're going through the field. We got these big beefy design bogies, and also our suspension system. So from level where it sits now, the rear part of this track, how it's suspended, It can rotate 10 degrees in downward direction and 15 degrees in the rearward direction. So if you want to talk about driving something about the size of a 2x4, we see a really smooth transition from front to end using the single suspension cylinder, keeping both this left-hand side arm and this right-hand side evenly suspended. From the tracks here, basically just to wrap this part up, we've designed these beefy to carry these big machines. You start talking about 485 bushel grain bin, you're going to see a lot of weight in there. These things can really handle a lot of weight, and we like what we've seen in the field so far. Wrapping up ground drives just a little bit, I want to take you guys to the rear part of the machine and touch on RWA. This machine is equipped with RWA. As you'll see down here, we have a 100 cc pump. That pump and motor will deliver about 2,800 newton meters of torque to the outside tires on this on the outside of this combine. The one cool feature about our RWA is we have a couple different options of how we use it. We have the on-demand mode, so that's basically on all the time whenever you have it on, so you're 100% full go all the time. We also have what we call our efficiency mode. You can activate that. You're only using the RWA when you need it. So if you're going through mud, you're going up a hill, you're losing a little bit of traction, you're seeing an increased pressure in your front drive, it'll start to activate somewhere around 4,300 PSI. So the efficiency mode helps keep us from using it when we don't need to and robbing a little horsepower. But it's also nice to have the on-demand all the time when you're turning in the field on in-rows, a little bit muddy soil, a little bit soft soil. It's a really nice feature we have. So as far as ground drives, that kind of wraps up what we have offered. We'd like to open it up a little bit to some questions that we had from you guys come across, and we'd like to reiterate those and get those covered. So,
okay. So one of the first ones we had was on the reversing fan for the AirSense cooling. The logic behind this AirSense cooling, and the question that we had in specific was, does it reverse every time the processor is shut off, like on our current Axial? So that logic is going to be built in the exact same way as our Gleaner combine, which is the same as the Axial in that reference to shutting off and reversing each time the processor is disengaged. So the parameters as far as the software goes, they will be identical to our Gleaner S9 and as our Axial combine, utilizing the FlexAir fan though, and that's a little different than our Axial combine. One of the other questions we had was in reference to auto lube. So the auto lube feature is something that will not be available on the Ideal combine. Now before we get too excited about that, I want to stress that the serviceability on this combine is only required weekly. So we only have 50-hour grease zerks. There's no daily maintenance required as far as that goes. And in addition to that, the banks that are available on the front of the machine as well as at the rear, they are very accessible, very easy to get to. So the idea to have that expensive auto lube system was a choice that we made to not have available. But once again, walking through the banks and the requirement of only doing it weekly, I think we'll be okay with that.
Real quickly too, a point about serviceability. The banks that Brent's talking about around the combine, there's only a few, but they're all labeled with the grease zerk how many hours too. So that's handy. When I'm walking around a combine, I'm like, oh, I see a grease zerk, I'm gonna grease it. No, it's labeled so that you know, and you can reset your counter in the terminal. So that really helps a lot with serviceability. Moving on to some more questions that we have. It was asked, how does the material flow around the lower 90-degree gearbox on the return elevator? That's a good question. One thing that's kind of hard to highlight here is on that cross auger. As you're coming through right before that gearbox, there's a paddle on the end of that auger. It lifts that crop up into a chute, and it lifts that crop up into the chute, and then that other auger, the vertical auger, has a paddle on it as well that'll grab that material as that comes around. So that's how we're able to jump up around that gearbox and get that material up into the cleaning shoe. Next question we had We want to know about the slip clutch for the feeder house. And then also, well, first I'll answer that question. So the slip clutch for the feeder house is on the top drive sheave on the right-hand side. We have that bottom sheave where you can variate between the 2 speeds, and then that belt goes up to the top sheave. That's where our feeder house slip clutch is at. That's the location of that there. We also were asked to verify if the feeder house is available as a 2-speed or variable speed. So the conveyor is offered as a 2-speed conveyor. The header drive is offered as a variable speed header drive, but you cannot have the 2-speed feeder drive, 2-speed conveyor drive without the variable speed header drive. So hopefully I cleared that up a little bit. So variable speed header drive, you can have a 2-speed feeder drive. Fixed speed feeder drive, you just have the 1-speed feeder drive. So hopefully that was able to cover some of your guys' questions as well.
Okay, very good. With that, we are going to transition into the cab, and this is where it really gets exciting as far as some of the technologies that we have offered with the Ideal Combine. It's a very smart combine, something that I'm really excited about. Some of the things we have in this combine we have never had in our equipment here today. So with that, we're going to head up inside the cab and take a look at some of the features that we have to offer. Okay, we are up inside the cab of the Ideal Combine. You're going to notice a very similar look and feel to what we have in some of our other products on the line today. Looking at the structure here on the right-hand console, we got that from Mark Torbadorf. You're going to see a lot of similarities in our Fendt lineup, our Challenger 1000 lineup, our Gleaner S9 lineup. So this is going to give our growers the opportunity to switch from any of our products and have a very similar look and feel as far as the operator station goes. The cab itself is beautiful. For those of you that have been in this cab, the nice panoramic view that we have from the front, the noise level, the cleanliness of this cab, the comfort inside this cab is very, very impressive. And looking at some of the competition out there today, they are all getting to have nice cabs. But some of the features that we have, those simple integrated foot pegs, some of those things that are cooled and heated seat, that really gives these growers the ability to stay in this cab for multiple hours a day, running into those long 14-plus hour days inside of a combine. We want to make sure they're comfortable. Well, what I would like to do in this little segment here is walk through some of the features that we have on the right-hand console. And what we're going to do, we're going to start down here in our bank of 4 switches. So our very first one is going to be our park brake. That's going to be the inside orange one. To engage and disengage, you simply lift, push forward. That will disengage, lift, push back, it will engage. The next one in line here is going to be our rear drive. So our RWA, to engage, you click forward, and that one will lock. So this would give us the opportunity now to have the 4-wheel drive engaged to give us that extra traction if need be. The 2 yellow switches are going to be very common to what we have today in our Gleaner S9. And in our Axial Combine, this is going to be our processor engage, click and lock forward, and our header engage, lift, lock forward. So at this point, we'd be running our header and spreader. And then the final one we can look at here is our engine RPM. So we can dial that up, and that will get us up to our full RPM on the engine. Just to circle back around on the reversing capabilities, this is a great time to talk about it. We talked about how to reverse the feeder. So if you were strictly wanting to reverse the front feeder house, you would pick up on this switch and you would reverse it. And then you would let off. That does not lock. To reverse the rotor, same thing. Lift up on the switch, pull back, and that gives us the ability then to reverse the rotors, the front rotor feeder, and then back down to our feeder chain system. Okay, so a very simple layout here. We didn't want to have it very busy for our growers. We want to maintain a simplistic design, and that's exactly what we were able to do with this system. As we transition over, we're going to take a look at our Zone C, we call it. So these are going to be all of your machine functions, some of our transmission drive functions as well. So we won't go through every single one of these, but just a quick overview. This is what we call our header hookup mode. We're going to get into how our hydro handle performs as far as the ground drive capabilities. And what we're using now is going to be a CVT style hydro handle response. It's not a true CVT transmission, but the functionality of our handle does respond like a CVT control. In order to disengage the CVT control and simply go back to a Z pattern, what we're used to in a combine, you would press and highlight this button, and then every time you move your hydro handle forward, it would react accordingly. Our simple transport mode, these give us the selections of our transmission to go from high speed to low speed, neutral selection, and in addition we have our diff lock. That will be standard on all combines, the diff lock feature. So anything related to ground drive is going to be highlighted orange. You can kind of see that here in the first bank. Next we'll highlight our green icons. These are going to be all of our machine settings. So to increase or decrease concave clearance or rotor speed, you would be using these switches here. This is your rotor speed, this is your concave clearance. Now your readout for these are going to be up in your monitor, and we'll go through those here shortly. The next column here is going to be for our fan speed, increase, decrease, and increase. And the other nice thing here is our chaffer is on top, our sieve is on bottom, but that's to adjust our cleaning shoe, the settings on our chaffer, and then down here on our sieve. Controlled from the cab as well are going to be our hydraulically folded grain tank extensions. So to open or close, you can do that right here, or you can do that through the monitor. Our streamer gates, we highlighted this earlier, but our streamer gates, in order to close or open that setting, will be done right down here on the blue icons on the back here. It'd be the center one. The final icon that I'll walk through is going to be our active spread tailboard, or it could be the passive spread with the electric adjustment. But this is where you'll adjust the direction of that discharge off your tailboard, left or right. Next we'll transition to our Zone D. And one of the things I'll inform you of is there was a lot of voice of customer that went into the design of this right-hand console. And some of the things over the years that we've taken away out of our combine cabs are some Zone D displays, maybe on that right-hand pillar, or having something just available as a secondary monitor. So once again, looking at trying to keep it very simplistic, listening to our customers on some of the things that they would like to view outside of the monitor. This Zone D will display our fuel and our DEF levels on the bottom left corner. It's also in the center going to display our loss. So we'll have loss from the rotor and from the shoe displayed on our Zone D. You have the silhouette of a combine down here in the bottom right corner. This will show you the swing of your unloading auger. Right now, with it green in the cradle, it's telling us that we have good positive engagement in the cradle, and that is fully retracted. When it extends out, it will also give you an icon that shows that it is in the extend process. And then when you finally engage the unloader, it will also show that there's crop extending out of the auger. So once again, a very, very simplistic view, but that was direct feedback from our growers, that they wanted to have this extra display to walk through and show them some of the basics. There is a small button on the right-hand side to shuffle through a couple of other items. Right now we have bushels in the tank being displayed, and I click it on the right-hand side. It changes it to % moisture, and then it will change it to our bushel per acre yield, and then back to our bushels in the tank. So there are some other things as far as ground speed and engine RPM. So the basics of what our machine is doing is going to be displayed down here in this right-hand console. Right below that are our ability to turn on and engage automatic header height control, our automatic tilt. This lever right here, the scroll wheel, will be for our reel speed. And then this scroll wheel right here will be for our automatic header height control set point. Next, we're going to move into our hydro handle. So this is what I mentioned is different than what we've had in the past with the CVT style control. Now, as far as the functionality, it's going to be a little difficult to see what each of the levers do, so I won't go through each of them individually. But the top wheel is going to be for our reel settings to raise it, lower it, extend it fore and aft. Down here is going to be for our header height, so you can raise, lower, tilt left, tilt right. And we have some other functionality on the right-hand side here. We're going to dive into headland management and the monitor. The ability to have headland management in a combine is very exciting for me when you're trying to do multiple settings at a time. Having the ability to engage those with the press of one button is really, really fantastic when we're looking at the operations side. The next icon down here is going to be our auto guide engage, and then we have our automatic header height engage right down here. So when we talk about CVT style control, this is what's different from our combines today. Our typical pattern that we have today in a combine is when you press forward, the handle will stay, and that's going to be forward motion. The further you press it forward, the faster you go, and then it will stay there. And then if you want to back up, you'll back it up, go over, and you're going to be in reverse. What's unique about the Ideal Combine and the control of it is phenomenal. Having the CVT style control and the logic built into this handle is outstanding. So how it works, you tap the lever forward, it will return to center every time, as a true CVT would. If you want to bump up your speed or increase it, you can tap it forward, and that will give you about a mile to 2 mile an hour increase in speed. If you press and hold it, you're going to aggressively increase speed. And once again, you can fine tune it, but keep in mind, this is going to return right back to where the operator's comfortable, right where his hand wants to rest all day. You tap your speed forward, it will maintain that speed until you make a change on this hydro handle. So this is really exciting. We've done a lot of training with our product specialist. And for those of you that have been in that Challenger 1000 or even ran that CVT, I've heard a lot of comments of how similar they react, even though this isn't a true CVT transmission. It's a CVT style control. So this is one thing that I'm really excited about. It's very comfortable to operate. The logic behind how to operate it is very intuitive as well. So we're going to do a quick dive into the monitor. Once again, this is our standard monitor that you're going to see in the 1000s and the Gleaner. But we're not going to go into too much detail at this point. We will send out a lot of information as the slides are communicated to the field. But just the quick overview that we have here. We have our combine settings that I talked about up here in the top left. We have some of our header height control settings over here in the top right. We can filter through our Harvest Plus data down here. We can look at our engines. We can look at our header, all this information. So there's a lot of things that our growers can look at and monitor while on the screen. Similar to what we have today, we have our combine in the top right corner. That will access our main settings that we have available. So one of the things I want to touch on before we transition into some really exciting technology is our headland management opportunity that we have. So if you press that icon, it's going to populate some of the items that we have available to function during headland management. I'll run through the list here real quick and kind of walk through a scenario, and then we're going to transition into some of our app functionality that we have available with Ideal. So on headland management, you have the ability to adjust header height control, reel speed, cleaning fan, guidance engagement, what we call constant flow, I'll walk through that, and discharge mirroring. On our hydro handle, to engage headland management, it is the top button that we walked through earlier during the demonstration. So if you have all of these items selected, when you engage your headland management, they're going to go to the operator set point that we had designated here. So if you want your header to drop down to a certain point each time you turn around on the headland, if you want your reel speed to slow down on the headland and then speed back up when you drop your header back down into crop. The big one that I want to discuss here is the cleaning fan. And I know you notice this on headlands when you look at a field that's been harvested and you look a week or two later, you see a lot of volunteer crop growing on the headlands. Having the ability when we pull out of the crop to slow down our cleaning fan speed is going to be very advantageous on our loss levels coming out of this combine. So having that ability on the fly to have this automatically adjust down or up, depending on if we're in crop or turning around on the headland, is very, very impressive. So this is something that we're going to have a lot better performance out of our combines. It's going to be consistent performance. It's something that are less control from our operators. All of these can be activated with the press of one button. So with that, we're going to transition to some of our neat features that we have available, and we're going to go through our app. And yes, we will have the ability to run an app through the Ideal Combine to monitor combine performance. The right-hand side, shoe distribution. And once again, you can trigger that all the way throughout that entire processor. From right now where we're at on the threshing area, you can trigger that back to the separation area, and you can look at the distribution on the shoe at that point. So in this example where we're at right now, we're showing that we're a little high on the right-hand side compared to the left. And once again, now it evens out. And not only on the rotor, but on the shoe, it's also showing the distribution. So this is a fantastic feature. It really gives our growers the opportunity to fine-tune performance if need be, if there are some issues with shoe distribution or anything like that. Now what we did on the bottom here is we went ahead and pressed the camera icon down by the right rear, or the rear tire. What this is a grain quality camera. Now what this logic in the software will look for is broken grain, MOG. It would look at either it's a stem, a stalk, it could be a piece of cob, and it's going to notice an irregularity of the software parameters that we have built into this system. So in this example, we are highlighting broken grain from wheat harvest. So what are some of the things that we can do then in order to alleviate this issue, maybe try to correct this issue? We have the opportunity, and some of this stuff that you're seeing in this right here, once again, this is going to be maybe not available right away for the demo season this year, but this is something that we're testing. So what I just did there is is I went to my selection triangle and I said that I want my combine to run to where it has less grain damage. Our grain quality camera showed that I had grain damage. I wasn't satisfied with it. I went to my selection triangle and I slid my selector over that says I want this combine to run to where it has more premium grain quality. So you can notice now some of the adjustments that could be automatically made, or it could be made by the operator manually, would be rotor speed. In order to improve grain quality, one of the things we could do is decrease that rotor speed. In addition, we could potentially increase that concave clearance to be less aggressive on that grain. If we go back then and look at our parameters right here, we're going to notice that our grain quality down here in the bottom right corner has gone down drastically. So you can monitor on this example, this bar chart that we have here. The left-hand side is your rotor loss, then shoe loss. Then you can look at your tailings, and then you can look at cracks and splits, and then you can look at your throughput capacity. So in this example, by adjusting that rotor speed down and increasing that concave clearance, we have improved the grain quality coming out of this machine. Now when we look back at our grain quality camera, we're going to see that the cracks and splits will have decreased. And this logic that we have here is going to be true for any crop. So that grain quality camera will work well with corn, soybeans, and canola and wheat. And the logic that we have built in for those parameters is going to function as needed to give that combine operator some information to make some informed decisions as far as what settings to use, some adjustments that he can make. And really, this functionality of this app is fantastic. It's going to give us some leading edge technology that's really going to help our growers in the industry today. So with that, we have once again a little bit of a break here, a transition before we go into our next slide. And I want to once again encourage you to take this time, a couple minutes, review some of the questions that you might have. We've gone through a lot of content up to this point. As you can see on the slide, if you do have questions, please email Caleb. It's at caleb.schlater@agcocorp.com. And once again, for him to filter them out, go ahead and put in that ideal virtual training subject line. And I just want to stress how important it is to build this confidence for you. We're once again doing this event for you. There's really no question that we're not gonna answer or take a shot at. There's no dumb questions that you can have at this point. So please take some time. If you want to send in a couple more questions, this will be about our last opportunity to go through and get those answered. So we're going to take about 5 minutes here for you guys to send those in, and we'll sit here and monitor the computer. And once we receive them, once again, we'll pull up on the camera and answer those the best that we can.
we're back.
And we're back.
All right, guys, we had a few questions come in over that break. We really appreciate you guys asking. This is a good chance for you guys to get all those questions off your chest. We had some good ones come in. The first one we've got is, what is the max road speed with the tracks installed? From what we've seen in the field, it's about 25.5 miles per hour. The next question is the RWA a single motor with drive shafts to outboard planetaries? Is it a Mud Hog product or an AGCO in-house design? So first question, it is a single motor with a planetary style drive. You nailed it on the head there. The drive shafts go right inside the rear axle, and it is an AGCO in-house product. So no longer a Mud Hog. We're all using in-house designs here. Next question we had, asking about the refresher. When is it needed? Well, why do we need to use it? And like I mentioned before, with the refresher, adding that refresher door is mostly for hard threshing small grains. The only place where I've seen in the field where it needed to be used, where it was any beneficial, was down in Arizona. You get high temps, and you really mash up that material. It's really dry material. So the more you clamp down on those concave and the tighter you get that adjustment, the more you really mash up that material. So sometimes you have a little bit of a hard time threshing. It's not a big issue that we've seen in the field, but adding that refresher door helps a little bit with white caps. That's the one instance that I've seen it happen in the field. So usually the rotors do all the threshing, and those refresher doors just help get the last few white caps out. So,
okay. Had a couple of other questions come in. So we're talking about the rotor reverser. So when we engage that reverser, will it also reverse the feeder house? And the answer to that specific question is it will not. But when reversing the rotors, if you remember, that front rotor feeder is also driven off and synchronized with the rotor drive. So when we reverse the rotor, it will reverse both the twin or single helix rotor and that front rotor feeder. If you do need to reverse the feeder house, that would be a separate action that you would need to do manually. Another good question that came in is, what is the weight of the machine? So I'm going to give you a range. With all the different configurations we have with header drive gearboxes, with tracks versus wheels, grain tank size is another good one, the length of the unloading augers. We're going to be anywhere from 40 to 50,000 pounds on this combine is approximately where we'll be on the weight. Another question came through, another great question. I'm glad you brought this up. So the other question is the clean grain elevator capacity of this machine. So of course we can give you the lab test studies, what we're able to carry through this in a lab test environment and a drier crop. The ability to take up to 7,000 bushel an hour through this clean grain elevator system was done on a lab test stand. Now, once again, as a disclaimer, you're not going to see 7,000 bushel an hour in ideal harvest conditions. You're going to be limited on some of those things that we have available. So just keep that in mind. That was on a lab test on the test stand. We can carry that much through if we can physically feed it through. In regards to header height control, I had another good question. On the presets for the header height, are there multiple locations that you can have available as far as set points for your header height control to return to? And the answer to that is yes. Our current system, we have either engaged on header height control or above the cutoff point. With Ideal, we're going to have header height control. We'll have a mid set point available as well, and then we'll have the break point. So there will be 3 locations basically available to switch between header height control on the Ideal combine.
Last few questions we're going to roll through right here. Can a customer monitor the combine app from outside the combine? So yes, that is possible. Now what it's doing is it's pulling the signal off the gateway, so it's going to be a lot like Wi-Fi. So I think good rule of thumb of Wi-Fi is about 100 feet. So you're not going to be able to sit on the road and guys a quarter mile away, and you'll still be connected close to the combine. Closer to the combine, the better your signal. So it'll be like a Wi-Fi type. Good question there. To wrap it up with our final question before we move on, it was asked if we have a chart or a formula to figure out soil compaction density on our tracks versus the tires, and yes, we do. There's a lot of numbers for me to spit out at this point to go over that. So what we'll do is when we hand out the slides for this training deck and hand out all the information for this, we'll include that as well. So that was a good question there. That's part of the information that we'll start handing out. And we'll keep that in mind and add that when the time comes. So, good question there. That wraps it up. We appreciate that, and I'm gonna hand it off to Caleb, and he's got a few final words here for you guys.
Thanks, Zach, and thanks, Brent. As you can tell, there's a lot of content, and I know we're past that 12 o'clock time period, but I'm going to ask that you stay on for just a little bit, because this next portion is really where the work gets done. This is what we're doing for 2018, so please stick around. As you can tell, this is just a fraction of what has been included into this machine. So there's a lot more content. We've essentially compressed down 18 hours of content into 3 hours to give you guys the first taste, that first bite. So as we go into trainings coming into this fall, as we go into more customer events, there's going to be more and more information that you can hold on to. But right now, we really wanted to equip you with those high level, those key features of the Ideal Combine. And Brent and Zach, they did a heck of a job. So great job, guys. What I'm going to do now is I'm going to talk about 2018. What does it look like for us and the customers to essentially go out and start work with the Ideal Combine? So what we're calling it is the Ideal Elite, and this is going to be directly related to your dealership. Those of you that are on this call, we were building a loyalty program based around your customers. And so we're going to jump over to a slide deck and talk about that. So we're going to switch over. And on this slide deck, you're going to see three phases. You're going to see the Ideal Engage, the Proving Grounds, and the Ideal Elite. Essentially, what this is doing is it's going to take a customer through a journey. We want to get them experience. We want to get them in front of a combine. That's Ideal Engage, and that's going to happen at our farm show customer events. Then we want to get them in the combine. We want to put them in the seats, so that's our Proving Ground events. We also have a dealer training element in there because we want to get you in the seat. We want to train you on operation, optimizing the combine. And then we have the Ideal Elite event, which is the dealer VIP event. So going from interest, building that interest, putting them in the seat, demonstrating, and then finally going to the Ideal Elite event at the end of the year and closing that customer and getting that pre-sale. So we're calling this the Ideal Elite. That's the customer group that we're building around it. So that is extremely key to this entire program. Now, when we switch over, what are we doing as far as launch for 2018? We're very happy to announce, and please keep this to yourselves until we do announce it, but we're going to be launching the Ideal Combine at the Regina Farm Show. That's going to be our first national show that we're going to show this combine, and it's extremely exciting because we're bringing it to a customer-centric focus. We wanted to go where our customers were. So Western Canada and Central Iowa, that's where we're going to place these combines. So we're showing it at the Farm Progress Show in Regina, then we're going to take it to the Farm Progress Show in Boone, Iowa. And then we also have some secondary shows, as you can see below, that we're going to be shipping machines back and forth. So at these events, that's where the Engage events take place. And so this is where we're going to ask for your help and your sales team's help and our account managers and our product specialists to work in conjunction with those farm shows and bring the key customers, the customers that you think that the Ideal Combine is right for, bring them to these events. The Engage event is to get them that first exposure. We'll have VIP events built around it, so customers will be able to come see the combine, experience walk-arounds with Brent and Zach and all of our product specialists that are the experts on this product, and really get that first exposure. This is going to happen at the Canadian Farm Progress Show and at Farm Progress Show. So at that event, we will then extend an invite to those same customers to come to the Proving Grounds. So what does the Proving Grounds look like? The Proving Grounds is essentially a demo team that we have built within AGCO. We'll have 4 demo teams that are going to be traveling throughout the U.S. and Canada that are designed to show the customers a positive experience around this machine. So we'll have a core team product specialist, 2 support specialists, and a service agent that is going to to be at each team and involved in this demonstration program. What we want is we want those customers that were engaged to come over and experience the machine in the field and get to operate it. So this is where that proving grounds is. And what we'll do is we'll have central locations that these customers can come and experience that. So here are the rough locations. Most of you that are on the call that have been involved in the Phase 1 dealer experience, you know where those locations are. You've already started thinking about who your cooperators are that we're going to work with. We want to make sure that we're putting it in a good location so our customers that come in get the best opportunity they can to see this machine in action. Here are our teams. This is just a quick look at what we have as far as the product specialists. Many of you know these guys. These are our product experts. They've been going through training for the past couple of months. They're going to go through more and more training leading up to harvest, so they're going to have really good tool set to make sure we're showing our best foot forward with our customers. Then we get to the Ideal Elite event. Now that's where we bring those customers that went to the Engage event, then they went to the Proving Grounds event. Now they're coming to the Elite event. This is so we can make sure we're bringing them back in, we're making them feel special, we're showing them a machine, and we want to essentially have them be advocates for us for that next year, those 2019 Ideal Elite customers. Building that pipeline, making sure we have a good customer base to continue our success forward. So when you tie all three of those together, what we wanted to do is just develop an Ideal Elite rewards program or a loyalty program. For guys that go and attend each of these events, we want to make sure that they feel as though they are special. They're important, they're elite, right? That's why we call them the Ideal Elite. They are the elite producers that are going to essentially be the first innovators and the first trailblazers that are going to take the Ideal Combine onto their operation and really see that positive impact from this machine. So you'll see there's 5 stages. The first one is the Ideal Insider. They're going to get a hat and a badge. And so what we're going to do is we're going to extend an invite to our sales team, and we'll send a communication out with that, and it's going to give you the tools necessary to go talk to those customers and invite them. So a portfolio with a brochure, with the Ideal Elite program guide, with the hat and with the badge, so we can go out and extend that to our customers and bring them into the Engage event. If they come to the Engage event, then you see they're going to get a Carhartt bag and they're going to get an invitation to the Proving Grounds. They come to the Proving Grounds, they'll get $5,000 off their purchase and an Elite Carhartt jacket or a jacket of some type. Then we'll get into the Trailblazer. They're going to win a trip to Agritechnica if they purchase. And then they'll also get a limited edition gift. And then finally you get to the Innovator, and that's a personalized letter and an iPad. So now you have an entire program to bring these customers and incentivize them to come to these events and really experience the Ideal Combine and make them feel truly elite. So here are a couple of examples as far as what we have that we are going to be sending out to everyone. Once again, a communication will follow after this. This is our initial launch of this program, so we'll do a much deeper dive. We wanted to focus on product here, and then we'll give you more information around the Ideal Elite at a later date. Then we get into the call to action. So now that we've walked through the Ideal Elite, what's the call to action? How do we get the work done? So what I'll ask of you is those of you that have taken the time and invested your time to be on this call, you now have a good idea of what the Ideal Combine can do, what it can provide to a customer from a high-level feature and benefit standpoint. So I need you to identify your elite customers, those guys that you think are the right customers for the Ideal Combine, the innovators, the early adopters, the high technology customers, and go talk to them, engage them, start communicating with them, and invite them to the Ideal Engage program that we have at either Regina or Boone. Make sure they're coming to those, because that's the first step to their journey. The other side of that is working with your AGCO team as you do this process. So you're working with your sales management team, and your AGCO team is helping you. We have OnTrack, which is a great tool that we can utilize for this. And we also have those key insights from you, the dealer, to make sure we're capturing those right customers. What we want at the end of the day are the right customers in the seat that are great potential for to be our future customers for Ideal. So with that, I want to go ahead and pass it back to the whole team. So we appreciate you taking the extra time. We know we went a little over, but there were some great questions that we wanted to answer. If there are more questions, we want to make sure that we do get those answered. So after this is over, we as a team will sit down and respond to you if we missed any of those questions as we were going through this. But once again, want to greatly thank Zach and Brent. They did a great job today. They're really insightful, and you can see why we position them as the product experts. And overall, thank you for taking the time. Nice. Richard, any closing comments?
Definitely. Very, very well. The guys have done a phenomenal job. You can tell they know the product. We're all excited. You can see now what this product and why we're so excited about having this product for us here in North America with all these wows and these differentiators that we're going to have with this product. So quite unique. Get excited. Find those right customers. The key really for 2018 for all of us is going to make sure that we identify those key customers, bring them to the different events that Caleb just went through, right, to make sure that there's a value for these customers. We realize that it'll be a task to get these customers away from their operations during harvest to come and see to these demos, but that'll be key to our success to show everybody that this is a phenomenal combine. So again, thank you for spending 3.5 hours with us, and thank you very much, guys. Job very well done.
Go get them, guys.
Thank you.
Customers.